Hello there, and welcome to Planet in Question, where curiosity takes a slower shape and science becomes a soft kind of storytelling. Tonight, we'll drift backward farther than history, farther than even the oldest fossils. We're traveling to a time when the world didn't yet know how to breathe, a time before the sky was blue, before plants reached upward, before anything with lungs could exist. This was the age when oxygen was new, an invisible, accidental miracle that would change everything that followed. As you settle in, maybe you're lying down, eyes half closed, feeling the steady rhythm of your own breath, the quiet expansion of air filling your chest, the gentle release that follows. It's something you do without thinking, something so natural you rarely pause to notice it. But for most of Earth's history, that act, the simple act of breathing, would have been impossible. The air itself was poison. And yet, in that harsh, alien world, something began to stir. Something small, patient, and luminous. Before we go further, take a slow breath now, the kind that fills you all the way down. The air entering your lungs tonight is the same air that once moved across oceans of stone, the same oxygen that once rusted entire seas red. It carries a memory older than language or stars seen through human eyes. Each breath is a kind of time travel. The atoms that sustain you are billions of years old, recycled through everything that has ever lived, ever burned, ever faded into dust. It's humbling, isn't it? To realize that what keeps us alive was once the cause of extinction, chaos, and renewal. If you find comfort in this kind of quiet, wandering science that hums instead of shouts, I'd be so grateful if you liked this video or subscribe to the channel. It helps these slow journeys find others who might need a bit of stillness too. We move gently here, like a current beneath the surface. No rush, no noise, just curiosity, uncoiled and soft. Now, imagine Earth as it was long before the first breath. The sky above you is not blue but coppery, thick with volcanic haze. The sun is dimmed by dust and gas, and its light scatters through an atmosphere heavy with methane, carbon dioxide, and sulfur. Lightning flickers across the horizon, and the air smells of minerals and storms. Beneath that strange sky, the oceans shimmer a dark green, filled not with fish or coral but with chemicals, iron, ammonia, and traces of life so small it could slip between the grains of sand. If you could stand on a shore back then, you wouldn't recognize the world as home. There would be no trees, no flowers, no sound of insects in the air. Just the endless hiss of waves against rock, the slow bubbling of gases rising from the deep. The continents were barren and raw, still forming. Mountains bled lava. Rain fell, but it was acidic, carving channels through young stone. The planet was alive in a different way, restless, unfinished, breathing not air but chemistry. And yet, in those greenish seas, something miraculous had already begun. Tiny organisms, invisible to the naked eye, floated in the shallows where sunlight could still reach. They were not plants, though they performed the same quiet work. These were cyanobacteria, blue-green microbes that learned how to take sunlight and water and, in a process both beautiful and dangerous, release oxygen as waste. It was the first time in the history of the world that oxygen entered the air in measurable amounts. The first time a planet known for suffocating skies began to exhale. But it didn't happen all at once. It was slow, achingly slow. For millions of years, these little architects of change released their invisible breath into the oceans. The oxygen didn't rise at first. It was immediately consumed, swallowed by the vast supply of iron dissolved in seawater. Every molecule of oxygen met with metal, oxidizing it, turning it into rust. The result? Oceans the color of blood. The world itself was rusting, layer by layer, painting its history into the rocks. If you've ever seen the red bands of ancient ironstone in cliffs or quarries, you've glimpsed that time. Those stones are the memory of Earth's first breath. They mark the beginning of something new, something that no planet in the solar system had ever done before. Mars had its dust, Venus its clouds, but only Earth learned to fill itself with air. At first, that oxygen was a disaster. The early microbes that dominated the planet didn't know how to survive it. Oxygen was reactive. It burned through their fragile chemistry like fire through dry grass. To them, it was poison. Whole populations of microorganisms vanished. In a way, The Great Oxygenation was Earth's first mass extinction. But extinction and creation often arrive together, and out of that destruction came a new kind of life. Organisms that could not only tolerate oxygen but use it. It's strange to think of oxygen as both destroyer and creator, but that duality has always been part of Earth's story. The same gas that allowed animals to breathe also corrodes metal, erodes mountains, and fuels every flame. Even now, every breath you take is both life-giving and aging. The oxygen that keeps you alive is also slowly wearing your body down, oxidizing cells, whispering reminders that even life comes with cost. But back then, in that ancient time, it was not about aging or decay, it was about possibility. With oxygen in the air, the planet began to change in ways that would ripple forward forever. Lightning struck differently, minerals oxidized into new colors, chemical reactions multiplied, creating compounds that made life more diverse, more ambitious. The stage was being set for everything we would one day recognize as home. Let's linger for a moment on that thought. The act of breathing something so simple, so quiet, is the outcome of billions of years of chance, catastrophe, and renewal. Every tree, every bird, every heartbeat owes itself to that slow transformation. Before oxygen, life was small, confined to water and shadows. After oxygen, life began to dream of movement, of light, of reaching upward toward the open sky. And so, as we begin our journey tonight, let's treat this as more than a story about chemistry or atmosphere. It's a story about awakening, about how a silent planet took its first true breath and began to speak in color and motion. The oxygen in your lungs tonight may contain atoms once exhaled by those first cyanobacteria, carried through oceans, trapped in stone, and released again through the slow grinding of time. In that way, we are all participants in a chain that began 3 billion years ago. So let's travel there, not quickly, but slowly, the way continents drift and tides move. Let's imagine that first dawn where the air began to shimmer with something new. The wind carries the faintest trace of oxygen, barely enough to register, but enough to begin changing everything. It's a fragile thing, invisible and unstoppable. The world is on the verge of becoming itself, and as you rest here, listening, breathing softly, remember, this moment, the one you're living right now, is built upon that breath. Every inhale is an echo of the first. Every exhale, a continuation of the oldest rhythm the planet ever learned. Tonight, we'll walk through that transformation together, through the silence before breath and the chaos that followed when the world filled its lungs for the first time. Because to understand what Earth was like when oxygen first filled the air is to understand what it means to be alive at all, to be part of a planet that learned how to breathe and never stopped. 1. The silent planet. Before oxygen ever graced the air, before anything had lungs or leaves or even the thought of breath, Earth was a planet wrapped in silence. Not silence in the way we experience it now, a calm night with wind and distant hums of life, but a truer kind, a deep, elemental stillness. The kind of silence that belongs to a world untouched by voice, by song, by movement larger than a wave. If you could have stood on the surface back then, you would not have recognized this place as home. The sky was not blue. It was thick, heavy, and colored in strange hues of orange, brown, or deep red. Its light filtered through a haze of volcanic gases. The sun would have appeared as a blurred disk, its rays struggling through clouds of methane and carbon dioxide. Lightning would have streaked through those skies, often brilliant, violent discharges that illuminated the mists, splitting molecules apart and stitching them together again into new forms. The air was not air as we know it. It was unbreathable, almost syrupy with greenhouse gases. Methane shimmered invisibly. Ammonia drifted in curls from the sea. Carbon dioxide hung dense, trapping heat close to the ground. It was a world both suffocating and cold in places, with wide variations that made the young planet unpredictable. The smell of sulfur would have been everywhere, sharp, metallic, the scent of earth still cooling from its fiery beginnings. There was no sound of birds, no rustle of trees, only the rumble of volcanoes and the hiss of vents releasing gas from the deep. At your feet, the ground would not be green with grass or soft with soil. It would have been bare, jagged rock, scattered with crystals of salt and streaks of minerals brought up from the molten layers beneath. There were no roots to hold the ground in place, no soil teeming with worms or fungi. Rain fell, but it carried acid, slowly carving channels through new stone. Over long stretches of time, the rain pooled in low basins, creating the first ocean's thick, dark waters filled with dissolved metals. The seas were not blue but greenish-brown, and under their surface they shimmered with strange chemistry. Iron and sulfur drifted freely in the depths, reacting with light in ways that made the water glow faintly under the sun. It was in those alien seas that life first found its fragile foothold. Not fish or plants, but something infinitely smaller, simple cells, barely more than chemical loops capable of copying themselves. They clung to mineral surfaces near volcanic vents where heat and chemistry met. There was no air to breathe, but there were gases to feed on. These earliest microbes consumed hydrogen and carbon dioxide, releasing methane into the water, and in doing so, they began to change the balance of the atmosphere, though no one and nothing yet noticed. The land above remained barren, a vast desert of stone and steam. But in the shallow parts of the oceans, something extraordinary began to unfold. Tiny, filament-like organisms gathered in colonies, forming mats that spread across the seafloor. They were early cyanobacteria, the architects of everything that would follow. They were the first to master a strange trick, using sunlight to split water molecules and steal the energy inside. In the process, they released something new, something invisible and immensely powerful oxygen. At first, the oxygen they made went nowhere. The oceans were rich with dissolved iron, and every bit of oxygen produced reacted immediately, binding to the metal and creating rust. Slowly, the ocean floor became layered with red. The entire planet was painting its own history in bands of iron oxide, line by line, year by year. Each layer was the record of a breath that could not yet escape. Above the water, the sky still held no trace of that oxygen. The air remained dense with methane, the greenhouse gases keeping the planet warm under a faint young sun. But beneath the surface, the chemistry was changing. The seas were turning from a toxic soup into something more reactive, more complex. The quiet revolution had begun. It was not loud, not fast, but steady and unstoppable. For millions of years, the cyanobacteria kept working, unaware of the world they were building. It's difficult to imagine this world without imposing our sense of life onto it. There were no colors in the way we understand them, no greens of forests or blues of oceans, because the very light scattering through the atmosphere was different. Everything would have seemed dim, tinted in shades of copper or brown. Even the sunlight that reached the surface was filtered through haze, weak and distant. And yet, the planet was restless. Volcanoes erupted endlessly, spreading black basalt across the land, creating new crust, releasing more gases into the air. Earth was still cooling, still shaping itself from chaos. Each eruption added to the heavy breath of the atmosphere, a breath still devoid of the sweetness we take for granted. There were no horizons filled with motion, no birds cutting through the air, no insects humming near water, only the ceaseless movement of clouds and the soft shimmer of light reflected off mineral-rich seas. Occasionally, a meteor would streak through the upper sky, leaving a brief trail of brightness that vanished into haze. The world was vast, but it was empty in a way that feels almost sacred. Every process was geological, chemical, slow and immense. And yet, in that emptiness, the seeds of transformation were already planted. The microbes drifting in the oceans were multiplying, spreading, evolving. They didn't know it, but they were changing the course of everything to come. They were writing the atmosphere from scratch. Over tens of millions of years, the iron in the oceans was exhausted. There was nothing left for the oxygen to bind with, nowhere else for it to hide. Slowly, it began to escape into the air. That moment when oxygen first began to accumulate was subtle, almost imperceptible. No thunderclap marked its arrival, no visible shift occurred overnight. But in the quiet of the deep past, the chemistry of the sky changed. The Earth, for the first time, began to exhale. Imagine what that might have felt like if the planet were alive in the way we think of life now. The first breath after an eternity of holding it in. oxygen rising, diffusing, transforming invisible layers of air. It was both a birth and a danger. Because to most of the life that already existed, this new element was lethal. Oxygen burned. It broke apart molecules that had once been stable. Entire microbial species suffocated in their own creation. It was as if the act of breathing poisoned the breather. But evolution has always been a dance of destruction and renewal. As one world died, another was being born. The silent planet was no longer so silent, not yet filled with sound or life, but beginning to stir. The chemistry of everything had changed, and from that change would come all the complexity of the future. The winds began to shift. Lightning struck new combinations into being. The first faint reflections of sunlight off oxygen molecules began to change the color of the sky, though it would still be millions of years before it turned truly blue. For now, Earth remained quiet, its silence humming with potential. The oceans continued to rust. The air thickened with the breath of microbes. Volcanic plumes rose into a sky that didn't yet know how to carry rainbows. Every process, every molecule, was building toward the same eventual outcome: a living planet capable of breath. So, picture it again. The world before air. The surface raw and new. The seas alive with invisible builders. The sky tinted with dust and methane. A planet waiting in patience, unaware that it was about to transform into something extraordinary. In that stillness, in that alien silence, the story of oxygen had already begun, quiet, unstoppable, and eternal. And from that stillness, the next great chapter would rise, the moment when that fragile breath became both blessing and burden, when life learned that to live meant to change the air itself. 2. The architects of change. If you could drift backward through time beyond the age of trees, past the rise of the continents, past even the first spark of multicellular life, you would eventually arrive at a world that looked nothing like the one you know. The surface of Earth would appear alien, almost unwelcoming. The air would sting your lungs, thick with gases that human bodies could not endure. The sea, strange and metallic, would shimmer not with fish or foam, but with floating mats of slime thin, rippling layers of microscopic organisms that stretched for miles like delicate green films. These were the architects of everything to come, the cyanobacteria, the quiet alchemists that would one day give the planet its breath. At first glance, they would have seemed insignificant, mere specks adrift in water, too small to be seen, too simple to inspire awe. But inside those tiny forms was the machinery that would remake the entire planet. They were the first to learn how to use sunlight, not just as warmth, but as power, how to take energy from light itself and transform it into life. They drew in carbon dioxide and water and, through the delicate dance of photosynthesis, released oxygen as waste. That simple act, turning light into food, releasing gas into the air, set in motion one of the greatest transformations in the history of the universe. The cyanobacteria didn't know they were changing the world. They didn't plan or choose. They were simply surviving, multiplying, dividing in quiet patterns across the shallow seas. Yet every second, every flicker of sunlight, they breathed something new into being. Their colonies grew thick and wide, layering upon themselves in mats that built up over centuries. Over time, these mats hardened into stone, forming structures we still find today, stromatolites, the fossilized echoes of their existence. You can see them even now in parts of Western Australia and the Bahamas, rounded, rock-like shapes rising just above the water, still built by descendants of those ancient organisms. They are living fossils, breathing reminders of that ancient revolution. If you could float above those prehistoric seas, you might have seen the shimmering green-blue glimmer of light scattering off the microbial surface. The water around them would be cloudy, heavy with minerals. Iron flowed freely in those ancient oceans, unoxidized and hungry to bind with anything reactive. When the cyanobacteria released oxygen, it was quickly devoured by that iron, turning the seas rusty red. Beneath the waves, layer upon layer of iron oxide settled onto the seafloor, forming the banded iron formations that today are mined as ore. Each stripe of red stone marks a heartbeat in the story of oxygen's birth. For millions of years, the oxygen never reached the air. It remained trapped in the ocean, consumed as fast as it was made. The balance was delicate. Each molecule of oxygen created was immediately absorbed, used up in reactions that turned the sea into liquid metal. The atmosphere above remained heavy with methane, its orange hue filtering sunlight into strange, dim tones. The Earth at that time was not the blue and white marble we see from space. Now it was darker, redder, more muted. But beneath that strange sky, the architects of change worked tirelessly. The power of photosynthesis was subtle but immense. It took sunlight, something that bathed the entire planet, and turned it into a chemical engine. Every pulse of light became food. Every molecule of carbon dioxide turned into fuel, and every byproduct of that process, oxygen, drifted unseen, waiting for a future it could not yet shape. Slowly, almost imperceptibly, the balance began to shift. As the oceans filled with rust, there came a moment when the iron was nearly all bound, nearly all spent. For the first time in the planet's history, there was nowhere left for the oxygen to hide. And so, it began to rise. At first, the change was small, microscopic, invisible, measured only in tiny fluctuations of air chemistry. But over time, it grew. The atmosphere, once dominated by methane and carbon dioxide, began to thin and lighten. The new gas, oxygen, was reactive and restless. It bound with everything it touched. Minerals on land turned red with oxidation. Rocks weathered differently. The chemical tone of the entire planet shifted. And in the seas, many of the old life forms, anaerobic microbes that could not tolerate oxygen, began to die. To them, the very presence of this new molecule was deadly. The world that had sustained them for billions of years was turning hostile. What the cyanobacteria had done, without intention or awareness, was both creation and destruction. In their quiet pursuit of survival, they had triggered Earth's first mass extinction. It wasn't violent, not in the way later extinctions would be, with fire and impact and chaos. It was slow and chemical, a suffocation of an entire biosphere. The ancient, oxygen-free organisms vanished, their once thriving colonies collapsing. Yet, as they disappeared, others began to adapt. Life learned, again and again, to find a way. Imagine this transition from the perspective of the planet itself. A world that had known one kind of chemistry for billions of years now faced a new one. The air became reactive, the oceans transformed, the rocks changed color. It was as though the entire planet was learning to breathe for the first time, and breathing, even for a world, comes with growing pains. For the cyanobacteria, this new abundance of oxygen was not an ending but an expansion. They thrived in the shallows, spreading across coastlines and lagoons, building layered mounds that captured sunlight and shaped the edges of continents. Over eons, they filled the seas with the first stable source of oxygen, setting the stage for all that would follow. And though they were tiny, smaller than a grain of sand, they had done something that no mountain, no volcano, no storm could ever do. They had changed the composition of the sky. It's humbling to think about that kind of influence. The entire future of the planet, trees, animals, people, everything that breathes, was made possible by organisms that lacked even the simplest sense of awareness. They didn't know they were creators. They didn't know that their waste would become the foundation for fire, for lungs, for song, and yet, without them, there would be no us at all. Sometimes, in the modern world, we think of change as something dramatic, a discovery, a revolution, a moment that flashes brightly and vanishes. But the Great Oxygenation was the opposite. It was the slowest revolution in history. It unfolded over hundreds of millions of years, creeping forward molecule by molecule. It was change at the speed of stone, and yet it was unstoppable. The cyanobacteria had turned sunlight into a tool. They had learned to capture energy directly from the star that warmed their world. In doing so, they created the first self-sustaining system of energy transfer on Earth. Every leaf that waves in the wind today, every blade of grass, every tree that reaches upward is an echo of that first experiment. The mechanism of photosynthesis has barely changed in billions of years because it doesn't need to. It was perfected almost immediately, by accident, in the soft bodies of microscopic beings floating under a red sky. Even now, the descendants of those architects persist. In lakes, in oceans, in the quiet corners of coral reefs, cyanobacteria continue their ancient work. They breathe sunlight, exhale oxygen, and drift unnoticed by most of the life they made possible. The air you breathe tonight contains the same process, repeated endlessly, quietly, beneath the surface of the sea. If you were to stand on the shore of that ancient world, you wouldn't hear them, you wouldn't see their motion, but the entire planet would be humming with their work. Every ripple on the water would carry the faint whisper of oxygen rising upward, escaping into the sky, reshaping the unseen. And perhaps the most extraordinary part is how ordinary it would have seemed then. No explosions of light, no sudden awakening, just the patient pulse of sunlight meeting life, again and again, until the world itself was forced to change. The architects of change never meant to create the air we breathe, they simply existed. But in their existence, they set the planet on a path toward breadth, toward complexity, toward everything that would one day look back and wonder how it all began. The age of oxygen was dawning, and the world, for the first time, was beginning to fill its lungs. The architects had done their work. Now, the atmosphere itself would take over, reshaping land, ocean, and life forever. The planet had begun its long inhalation, the first breath of a living Earth. 3. The poisoned world. The rise of oxygen, for all its promise, did not arrive as a gentle gift. It came as a slow catastrophe, a transformation so complete that it nearly erased the life that had made it possible. For the early organisms that had thrived in the soft darkness of a methane-rich atmosphere, oxygen was not a breath of life. It was a toxin, a corrosive intruder. The world that had once been stable, familiar, and quietly thriving beneath copper skies was about to become dangerous. Imagine it, a planet that had learned a new language, but one that most of its inhabitants could not speak. The cyanobacteria, endlessly releasing oxygen into the water, had shifted the balance of chemistry forever. The oceans that once shimmered green with iron began to clear, their dissolved metals locked into rust that sank to the seafloor. Slowly, the ocean's color changed. It was no longer the dark, mineral-rich brew it had once been. It was becoming clearer, lighter, yet also more hostile to the life that had been comfortable in its depths. The atmosphere above, too, was shifting. As oxygen began to rise from the seas, it collided with methane, the greenhouse gas that had long trapped warmth around the planet. Oxygen destroyed methane in the air, replacing it with carbon dioxide, a weaker insulator. The Earth began to cool. The heat that had once kept the planet's young oceans liquid started to slip away into space. And as the balance changed, clouds thickened, sunlight scattered differently, and the surface began to shiver. In the beginning, these changes must have been invisible to the creatures that lived through them. The microscopic colonies floating in the seas could not comprehend the danger growing around them. They divided, fed, multiplied, following instincts that had worked for billions of years. But the chemistry of the world they depended on was no longer theirs. Their own success had turned against them. Oxygen infiltrated their cells, ripping apart molecules, breaking down membranes, interfering with the delicate reactions that sustained them. For life that had evolved in a world without air, oxygen was a silent predator. Across the planet, the old ways of living began to fail. Vast microbial communities collapsed. The mats of life that once spread across shorelines turned pale and thin. In the deep ocean, where oxygen seeped down through layers of water, it poisoned what it touched. The anaerobe organisms that could not tolerate oxygen retreated into narrow refuges, the bottoms of lakes, the cracks of rocks, the mud under the seafloor. There, in darkness, some managed to persist, hidden from the new and burning air. They are still there, even now, tiny holdouts from that ancient world, living fossils that never adapted to the great change. But not all life perished. Some found ways to endure. Some discovered how to use oxygen not as a toxin, but as fuel. It was the ultimate act of adaptation, turning poison into power. In the chemistry of oxygen lay an incredible energy, a new form of metabolism far more efficient than anything that had come before. Organisms that learned to breathe this strange new gas gained strength and speed beyond what their ancestors could have imagined. They became the ancestors of all aerobic life, everything that would one day run, fly, think, or dream. The planet, meanwhile, was entering one of its most dramatic transformations. With methane gone and oxygen taking its place, temperatures dropped further. The skies thinned. The air lost its reddish tint. For the first time, the heavens began to pale, scattering light differently, foreshadowing the blue that would one day fill our days. But the price was immense. The earth began to freeze. Ice crept across the land, reflecting sunlight back into space, amplifying the cold. The more the planet froze, the colder it became, a feedback loop of glittering devastation. Some scientists believe this period led to what we now call snowball Earth, a time when glaciers stretched all the way to the equator, and the oceans lay beneath thick crusts of ice. Whether the freeze was total or partial, it was catastrophic. The world of open seas and active life gave way to a nearly silent planet locked in white. Beneath that ice, faint traces of warmth persisted: volcanic vents, geothermal pools, cracks where the ocean still moved. It was there, in those hidden places, that life endured the long freeze. It's difficult to imagine what such a world would have looked like. The sun, dim and distant, shining faintly over a white and grey desert of ice. The sound of wind sweeping across frozen plains, the crack of glaciers moving inch by inch. Beneath the ice, water flowed sluggishly, carrying with it the last refuges of warmth, of colour, of motion. The oceans beneath would have glowed faintly in shades of green and red from the surviving microbial mats, clinging to hydrothermal vents that released both heat and chemicals into the water. They were the last bastions of the ancient world, surviving through patience and chemistry. To the planet, this was a cleansing, a rebalancing. The oxygen had changed the air, the cold had changed the sea, and together they reshaped every inch of Earth's surface. Volcanoes continued to erupt under the ice, pumping carbon dioxide back into the sky, slowly, steadily, until the greenhouse effect began to return. After millions of years, the planet began to warm again. The glaciers receded, the air grew clearer, the seas thawed, and when the ice finally melted, what emerged was a different world. The Earth that came out of the freeze was not the one that had gone in. The air was no longer a suffocating soup of methane and haze. It was lighter, fresher, touched by oxygen. The skies, at last, were blue. The sunlight that reached the surface was brighter and gentler. For the first time, the planet looked alive, even if the life upon it was still small and quiet. And yet, the memory of the poison lingered. Oxygen was not kind. It corroded, it burned, it oxidized everything it touched. It was as if the planet had traded one danger for another. But the life that remained had learned to live with it, to balance creation and decay. The world had moved from chemistry to metabolism, from stillness to rhythm. When you look at the sky today, when you see that endless blue stretching overhead, it is easy to forget that its color is born of catastrophe. That the very gas that fills your lungs was once a destroyer. Oxygen is life, but it is also death. It burns in every flame, rusts every metal, and wears away the surface of every stone. It is both gift and consequence, creation and cost. In that ancient era, the earth became a place of contrasts. The seas glowed with life, but the land remained barren. The air was fresh, but still dangerous in its newness. The creatures that survived had learned resilience beyond measure. Some adapted to oxygen, others hid from it. The planet's chemistry was now divided between two realms, one of light and breath, and one of darkness and silence. Every living thing that came afterward would inherit that duality. The act of breathing, the very thing that sustains us, would always carry with it a trace of peril. Every inhale is a quiet acknowledgement of that ancient balance. Every exhale, a reminder that survival was never guaranteed. As the world thawed and light returned, the survivors began to explore their new possibilities. Oxygen, once a toxin, had become a tool. The long freeze had wiped the slate clean, clearing space for new forms of life to emerge. It was as though the planet had been reset, its chemistry rebalanced, its potential renewed. And through it all, the cyanobacteria continued their work steady, patient, eternal. They had outlasted the poison they had created, endured the freeze they had triggered, and carried on producing the air that would one day give rise to forests, oceans, and the soft sound of human breath. They were the quiet engineers of survival, the reason the world was able to begin again. When the ice melted completely and the first blue skies shimmered above the open water, the earth took what could only be described as a breath of relief. The poison had become the cure, the destruction had become the foundation, and life, fragile, persistent, magnificent, had learned once again how to endure. It's strange to think that every breath you take carries that legacy, that the oxygen filling your lungs tonight was once a deadly gas rising through ancient seas, born of bacteria that nearly killed the planet that made them. And yet, without that disaster, nothing that came after would exist. Sometimes the world must poison itself to begin again. Sometimes creation is indistinguishable from collapse. And in that paradox, the planet found its rhythm, the balance between breath and stillness, between danger and life. 4. Rusting oceans, red rocks. When the first traces of oxygen began to spread through the seas, the earth started to change color. It happened slowly, so slowly, that if you could have stood on a shore and watched, you would not have noticed anything at all. The waves would have looked the same, the surface of the water reflecting the same hazy orange light from the methane-filled sky. But deep beneath those waters, something invisible was unfolding, something that would leave marks in stone that would last for billions of years. The oceans were rusting. The water of that ancient world was not like ours. It was thick with dissolved metals, iron and nickel, and other elements drawn from volcanic rock. The young planet's crust was still soft in places, constantly reshaped by heat and pressure. Rainfall, acidic and warm, eroded those surfaces, washing their minerals into the sea. There, the iron floated invisibly, turning the water a dull greenish-brown. It was a metal ocean, glittering faintly under the dim light of the sun, and when oxygen appeared, it found a ready partner. Each molecule of oxygen produced by cyanobacteria was drawn immediately into a chemical embrace with the iron drifting in the depths. The reaction was swift, unstoppable, and immensely beautiful in its simplicity. The oxygen stripped the iron of electrons, turning it into rust iron oxide which precipitated out of the water like dust falling through light. It settled on the seafloor, forming thin red layers of sediment. Wave after wave, century after century, the iron reacted, fell, and collected. The seas were painting their own story, writing in red and grey. These layers became what we now call banded iron formations, and they still exist, ancient ribbons of colour frozen in the rock of the modern world. If you've ever held a piece of red jasper, or looked closely at the iron-rich cliffs of Western Australia or Canada, you've seen the memory of those first breaths. Each band in those rocks is the fossilized rhythm of Earth, learning to breathe oxygen, rising, reacting, resting, and then rising again. The planet was recording its own transformation in stripes, the way a tree records its years in rings. Imagine walking along those shores billions of years ago. The landscape would have been strange, bare, metallic, almost alien. The sound of wind would echo across stone. The seas, under certain angles of light, might have shimmered faintly red or copper, depending on the density of rust particles suspended within them. The sun's reflection would flicker, distorted by the metallic haze of the water. It must have been haunting and still, a world in the middle of rewriting itself. The oxygen, of course, was not trying to create beauty. It was following the unfeeling laws of chemistry, spreading outward wherever it could find something to bind with. It filled the seas first, then crept into the rocks, then the air. But at every stage, it left traces. Iron turned to red stone, manganese turned to black, sulfur turned to pale crystal. The palette of Earth was changing. For the first time, the planet began to show color that was not merely light and shadow, but chemical memory. The transformation was not uniform. Some parts of the world remained free of oxygen for millions of years. The deep oceans stayed dark, cut off from sunlight, where ancient anaerobic life continued to survive, unaware that its world was shrinking. But in the shallows, where light touched the microbial mats, the reaction was relentless. The mats grew thick, capturing sunlight, releasing oxygen and trapping sediment. Each wave that washed over them added another layer to the stone that would one day be revealed as stromatolites' living sculptures, shaped by time and light. It's strange to think that so much of our planet's texture, its iron mines, its rust-colored deserts, its veins of hematite, was born from those unseen processes. What we now dig from the earth, melt into steel, and shape into cities was once the byproduct of invisible microbes drifting through ancient seas. Every bridge, every train, every nail is, in some distant sense, the descendant of that oxidation. The very tools of our civilization are made from the residue of life's first great experiment. Over time, the oxygen began to saturate the ocean completely. The iron was consumed, there was nothing left for it to bond with, and so the oxygen began to rise, seeping into the atmosphere. The seas, once coloured with rust, grew clearer, their chemistry transformed. The air, still filled with carbon dioxide and methane, began to shift. For the first time, traces of ozone formed a thin layer of gas high above the planet that would one day protect it from the harsh ultraviolet light of the sun. But the beauty of this transformation came with consequence. As the oxygen increased, it continued to destroy methane, reducing the greenhouse effect and cooling the planet further. Storms grew stronger, clouds more reflective. Ice crept outward from the poles, glinting faintly beneath the dim sun. In places, the rusted seafloor was buried under snow and ice, sealing those ancient layers like a memory in glass. The Earth was entering one of its long hibernations, and yet beneath the cold, life continued to breathe. The colour red, though, remained. It was the planet's new signature. Across its surface, the freshly formed rocks glowed with hues of ochre and crimson. Even today, you can see echoes of that time in deserts and mountains where iron is abundant. The same oxidation that turned those ancient oceans to rust continues in every rock exposed to air. Every time you see a reddish canyon or a rusted metal fence, you're witnessing the same process that began billions of years ago, a slow conversation between air and stone. The banded iron layers also became the Earth's first permanent archive. Unlike fossils, which could be erased by time and heat, these layers endured. They are as close as we can come to reading the heartbeat of the planet during its first breaths. Each stripe tells us that oxygen was not a steady arrival, but a rhythm rising and falling in waves, advancing and retreating as life and climate danced their slow dance. For millions of years, the Earth alternated between oxygenated and anoxic states, its chemistry shifting like tides. It's beautiful to think that even chaos has rhythm. The rise of oxygen wasn't an explosion but a song, one written across stone and ocean. And though no ear could hear it, no eye could see it, the entire planet was resonating with that transformation. The air itself was learning to shimmer. As the rusting continued, the smell of the world would have changed too. Where the air once stung with sulfur and methane, there would have been new scents, metallic, sharp, clean in a way that only oxygen can be. The rain would have felt different. Its acidity lowered, its clarity increased. Each drop that fell was part of the planet's slow purification. And in that quiet transformation, the groundwork was laid for everything to come. The rusting oceans were not just a symptom, they were a transition. The oxygen that turned the seas red would soon turn the skies blue. The metals that fell to the seafloor would harden into continents rich with ore. And the same oxygen that had poisoned the ancient world would become the foundation for new forms of energy, complexity, and motion. In the calm that followed the Great Freeze, when the ice melted and the sun rose brighter through the thinning haze, the seas would sparkle again, not with rust, but with life. The oxygen levels continued to rise, and with them came the promise of something new. Cells began to change. They learned to use this volatile element not just to survive, but to grow stronger. But before all that, there was the era of red oceans, of chemical beauty born from catastrophe. The world was quiet, but not empty. Every ripple on the surface carried within it the story of transformation, of creation born through destruction. And beneath those waves, the iron was settling, forming the foundation of continents and the colour of time itself. Billions of years later, when you hold a piece of that red stone in your hand, you are holding the memory of that moment, the instant when the planet learned to change itself, when the sea turned to rust and the air began to breathe. It's a story not just of chemistry, but of patience, because that color, the color of iron, of blood, of the Earth's earliest dawn, has never truly left us. It lingers still, in every desert, every canyon, every twilight where sunlight meets dust and glows red against the horizon. It is the planet remembering its first transformation, its first breath of color, and the beginning of everything that would follow. 5. The long freeze. There are moments in Earth's story when creation and destruction arrive in the same breath. When something beautiful gives rise to something terrible. When progress feels like punishment. The Great Oxygenation was one of those moments. Out of the tiny breath of microbes came a transformation so vast it remade the planet and then nearly erased life itself. For when oxygen filled the air, it didn't just change the chemistry of the oceans, it changed the sky. And when the sky changed, the world began to freeze. At first, it would have been subtle. A slight cooling of the seas, a thinning of the haze that had once wrapped the planet like a blanket. Methane, the gas that had warmed the young Earth for billions of years, was being destroyed by oxygen. The greenhouse effect, once so thick that it kept the planet cozy under a faint young sun, began to weaken. The balance of heat slipped. The warmth that had once been trapped near the surface began to escape back into space. The sun's light, scattered through the changing air, grew paler. The days seemed a little clearer, the nights a little sharper. Then, gradually, the cold deepened. The oceans cooled further, and ice began to form at the poles. At first, it was temporary seasonal layers that melted each summer. But as the planet reflected more sunlight from its growing ice sheets, it cooled even faster. The white spread outward. It crept down from the poles toward the equator, one slow glacial breath at a time. The more it grew, the more sunlight it bounced away. The feedback loop was merciless. Ice invited more ice. Reflection fed reflection. And eventually, the Earth crossed a threshold from which it could not easily return. Imagine that moment. Imagine standing on the ancient coastlines, watching the seas begin to stiffen into sheets of glass. The air so cold it bites even in imagination. The once dark oceans shimmering beneath a sky now pale and thin. Snow falling in places that had never known it before. It would have been the soundless kind of cold, the kind that mutes everything the wind subdued, the waves slowed, the air holding its breath. The entire world was turning white. Scientists call this time Snowball Earth, though the name can sound almost playful, like something that should melt by spring. But this freeze was no passing season. It lasted for millions of years. Glaciers spread across continents, carving mountains into smooth stone. The oceans, sealed beneath thick ice, darkened into quiet prisons of water. Even the equator, once warm and filled with storms, was locked in frost. From space, the planet must have looked like a pearl, shining, still, and silent. And yet, even in that silence, life did not vanish. Beneath the ice, in the unseen places, it endured. In the dark ocean depths, where heat still seeped from hydrothermal vents, communities of microbes clung to existence. Around volcanic openings, in cracks of the crust, in the slow warmth of the seafloor, life continued. It didn't flourish, but it persisted. Every bubble of gas that rose from the vents carried a whisper of survival. Every chemical exchange between rock and water kept the faint rhythm of metabolism alive. Above, the ice reflected starlight and moonlight in equal measure. The sky, once copper with methane, was now nearly clear, but there was little light to see. The air was thin and brittle. Winds moved with eerie precision, shaping dunes of snow across ancient volcanoes. Even time must have felt slower then, measured not in days, but in centuries of frost. And in that long, frozen age, the planet rested. It's tempting to think of that rest as death, but it wasn't. It was gestation. Under the ice, carbon dioxide from volcanoes continued to build in the air, little by little. The volcanoes never stopped breathing, even when the oceans froze above them. Each eruption released gases that the frozen seas could not absorb. The atmosphere, trapped under its reflective shell, began to thicken again. It took millions of years, but the accumulation grew. The balance began to tip once more. Eventually, the greenhouse effect returned with vengeance. The air, saturated with carbon dioxide, began to trap more heat. The ice, once impervious, began to weaken. At first, the change would have been invisible, slight cracks forming, tiny rivers of meltwater trickling through, but those rivers widened, pools became streams, streams became floods. The planet began to thaw. When the melt finally came, it was not gentle. It was chaos. The white crust of ice collapsed into water. The sunlight that had been reflected for eons was suddenly absorbed, and the planet warmed rapidly. Oceans surged, levels rose, storms raged. It was as though Earth had taken one long frozen breath and was now exhaling all at once. The glaciers retreated, the air filled with mist, and the colour returned. The blue of open seas, the red of iron-rich rock, the brown of bare land. The world was awakening from a long sleep. What remained after the thaw was not the same planet that had frozen. The air was clearer, the chemistry transformed. Oxygen still filled the skies, but now it mingled with carbon dioxide in a new balance. The continents had shifted under the weight of ice. The oceans had turned over, mixing their layers, redistributing minerals and nutrients. It was as if the freeze had stirred the planet's contents, resetting everything from the bottom up. For life, the long freeze had been a crucible. The species that survived were those that could adapt to extremes, those that could slow their metabolism, hide in darkness, and find energy in the most unlikely places. And when the thaw came, those survivors emerged into a world of possibilities. The air was rich with oxygen. The oceans, newly oxygenated from top to bottom, were ready to host new kinds of complexity. The stage was set for evolution to accelerate. It's a strange thought that a global disaster could become the seed of everything that followed. But the Earth has always operated in paradox. It destroys to make space for creation. It freezes to cleanse, then thaws to renew. The long freeze, terrible as it was, prepared the world for life as we know it. It enriched the oceans with minerals, cleared the sky, and gave rise to a planet where light could finally reach deeply enough to awaken the next great wave of life. If you close your eyes and imagine it, you might see the transition. The ice retreating slowly, revealing rock polished to a mirror sheen. The first thin fog rising over open water, glowing pink under the ancient sun. The quiet hiss of waves returning to shore after millions of years of silence. Somewhere in the shallows, a colony of microbes stirs, sensing light for the first time in ages. They begin to photosynthesize again, releasing oxygen into a world newly ready to receive it. The cycle begins anew, but now there is memory in it, an awareness, written into the chemistry of the planet, that balance is fragile and change is constant. Even now, traces of that frozen era remain. The striations in mountains, the glacial deposits hidden beneath layers of sediment, the isotopes locked inside stone, they all whisper of a time when Earth turned to ice and waited. The rocks remember what we cannot. They hold the silence of those frozen centuries, the stillness that came before everything bloomed again. And in a way, we carry that memory too. The oxygen that fills your lungs tonight was once a participant in that freeze, trapped in ice, held for eons before being released. When you breathe, you are completing a cycle that began long before the first forests or creatures, when the world itself took its first slow, trembling breath. The long freeze was the planet's pause, the moment between inhale and exhale, between chaos and renewal. When the thaw came, the Earth breathed again, and life emerged not as it had been, but as something new. The oceans shimmered, the sky cleared, and the planet, reborn, prepared to dream in color. The red seas had turned blue, the cold had given way to warmth, and beneath the sunlight of a brighter sky, the world opened its eyes once more. 6. Light returns. When the long winter of the Earth finally began to thaw, it did not end with a sudden roar or a blazing sunrise. It ended the way most great changes do, quietly, imperceptibly, one small shift at a time. A single drop of water sliding down a frozen surface, a faint crack echoing through ice that had been silent for a million years. The sun, pale and weak behind clouds of carbon dioxide, began to reclaim the planet by degrees. one breath of warmth at a time. The white mirror that had once reflected nearly all its light back into space started to fade. Blue returned first to the equator, then to the mid-latitudes, then to the poles. Slowly, the Earth remembered color. If you could have floated above the planet during this transformation, you would have seen something astonishing. The white globe that had once looked like a marble of glass was changing. The ice was breaking, and through its cracks, the dark blues of open ocean gleamed like veins of sapphire. Glaciers carved into the sea, sending thunderous waves that rippled across thawing continents. The air filled with vapor again, with clouds and storms and the long-forgotten rhythm of rain. The silence of the frozen world gave way to sound the groan of melting ice, the rush of rivers, the soft percussion of water striking stone. After millions of years of stillness, the planet was awake once more. The return of liquid water changed everything. The oceans stirred, mixing their long, separated layers. Nutrients that had settled into the depths during the freeze rose again toward the light. The upper waters, touched once more by sunlight, became laboratories of possibility. The cyanobacteria, patient survivors of the ice, bloomed again in enormous numbers. For the first time in a long time, they felt warmth on their membranes, light on their pigments. They resumed their ancient work drawing in carbon dioxide, releasing oxygen, stitching the atmosphere back into life. The Earth was breathing again, but differently this time. Before the freeze, the oxygen had poisoned many of its inhabitants. Afterward, it became the foundation for renewal. The long stillness had reset the balance. The air was clearer now, the skies thinner, the sunlight sharper. The dim orange haze of methane was gone, burned away by chemistry and time. What replaced it was something new, the faint, pure blue of oxygen scattering sunlight through the thinning air. It was the first time the planet truly glowed with the color we now call sky. The transformation of the sky would have been slow, almost ceremonial. At first, it might have appeared as a faint gradient above the horizon, blue blending into white, then into darkness. But as the oxygen accumulated, that color deepened. The light that once filtered weakly through haze could now scatter freely, painting the atmosphere with serenity. The blue sky was not just an aesthetic change. It was a chemical declaration. The planet had entered a new era. The age of air had begun. On the surface, new rivers carved through melting ice, carrying minerals from land to sea. Those minerals, iron, phosphorus, silica, fed the organisms below. The oceans blossomed with life again, not yet complex but abundant. Where once there had been ice, there were now swirling blooms of cyanobacteria and algae, painting the seas in emerald and turquoise. Under the right angle of light, the surface of the water would have glowed with soft green tones, shimmering like glass as far as the eye could see. The world, once white and silent, had become a living mosaic. The warmth brought back the cycle of evaporation and rain. Clouds drifted across the sky, heavy and bright, scattering light and shadow across the new oceans. Lightning flashed again, splitting nitrogen in the air and feeding the chemistry of life. Thunder rolled over continents that had been buried for millennia. It must have been a sound both terrifying and sacred, the sky announcing its return. Yet, this new warmth came with its own kind of danger. The ice that melted so quickly sent massive floods into the oceans, raising sea levels, altering currents, and changing the climate in unpredictable ways. Storms grew vast, sweeping across the continents with torrential rain. The Earth was relearning its balance, adjusting to its own breath. But within that turbulence was renewal. Every flood carved new valleys. Every storm mixed the atmosphere. Every gust of wind helped distribute the air that would soon sustain everything that moved and grew. The sunlight, now freed from its prison of ice, reached deeper into the water than it ever had before. For the first time, entire layers of the ocean glowed with light. It wasn't just energy, it was invitation. It beckoned to life, urging it toward complexity. In the shallows, the cyanobacteria formed new colonies, dense and organized, layering sediment into new stromatolites. In deeper waters, new species of microbes began to evolve ways to use oxygen in their metabolism, drawing energy more efficiently than their ancestors ever could. The slow machinery of evolution began to turn faster. It's almost poetic to imagine the planet at this moment waking from a long sleep, blinking in the brightness of its own survival. The cold had nearly ended everything, yet it had also cleared away the chaos of the old world. The Earth that emerged was cleaner, calmer, more stable. Its skies were breathable, its oceans fertile. The stage was being set for the next great experiment, multicellular life. But for now, the world was content simply to shine. The blue of the sky and the green of the water were new colors in the universe, never before seen. Somewhere out there, if any eyes had been watching, they would have seen a faint dot shimmering in blue light, a sign of a living world, freshly reborn. The same light that now filters through our atmosphere and paints our sunsets began then, when the first true oxygen scattered sunlight into color. Every dawn, every twilight, every moment when the sky shifts from gold to indigo is a direct descendant of that transformation. The beauty of the modern world began there, when light returned to a planet that had once forgotten how to shine. As the millennia passed, the thaw stabilized. The continents settled, volcanoes erupted less often, and the balance of gases in the air grew steady. For the first time in the planet's long, chaotic history, stability began to take hold. It was fragile, but it was enough. Enough for life to expand, enough for ecosystems to form, enough for the chain of evolution to weave itself forward toward complexity. The first true atmosphere, oxygenated, balanced, alive, had been forged not through peace, but through struggle. Every breath of air carried the memory of extinction. Every wave of the sea carried the echo of ice. Yet from that mixture came harmony. The oxygen that had frozen the world now sustained it. The carbon dioxide that had once thickened the air now regulated it. Even the nitrogen, inert and quiet, played its part, forming the invisible cushion that held everything in equilibrium. If you stand outside today and look up at the sky, that same balance is what surrounds you. The blueness above you is not just air, it is history. It is the color of recovery, of resilience. Each photon of light that bounces through the oxygen molecules above you is a reminder of the thaw, of the return of warmth, of the moment when the world decided to keep living. The long freeze had nearly silenced the planet, but light returned and filled the silence with color. The glaciers receded, the seas breathed, and the air shimmered with the brightness of renewal. From that brightness, everything else would follow. The forests, the creatures, the voices, the laughter of humanity, all of it was written in that moment when the first true sunlight touched an oxygenated sky. The earth, once again alive, turned gently toward the sun, and the age of light began. 7. The breathable miracle. The air we breathe today feels so ordinary that it's almost impossible to imagine a time when it didn't exist. Every moment, without thought, we draw it in and let it go. Inhale, exhale. It's a rhythm so simple, so automatic, that we forget how much history it contains. But the first time Earth made air that could truly be breathed, it was nothing short of miraculous. It was the moment the planet transformed from chemistry to atmosphere, from a place that merely existed to one that could sustain life that would someday look up and wonder how it all began. When the ice of the long freeze finally gave way and the sunlight began to scatter freely across the oceans, the planet's air began to change once again. Oxygen, once a dangerous byproduct of microbial life, had found a home in the atmosphere. It no longer vanished into the sea or bound itself to minerals on the seafloor. It lingered, it spread. Slowly, it began to fill the sky. At first, the air must have felt thin, almost shy. The balance of gases was delicate, too much carbon dioxide to breathe, not enough nitrogen to cushion the warmth. But each day, the cyanobacteria kept at their quiet work, transforming sunlight into chemical life, turning water into air. Oxygen was released, molecule by molecule, until it became a constant presence, a faint perfume of vitality drifting over the waves. There was no sound to mark the moment when the air became breathable, no thunderclap or cosmic signal. It was a gradual alchemy, invisible but unstoppable. The world that had once been toxic was learning how to host its own continuation. The atmosphere reached a tipping point. just enough oxygen to begin supporting new chemical reactions, new kinds of metabolism. The line between survival and suffocation began to shift. For billions of years, life on Earth had lived without breath. It fed on minerals, heat, and the faint energy of chemical bonds. But now, with oxygen in the air, the rules were changing. Oxygen offered a kind of energy that nothing before had known: clean, efficient, and powerful. For the first time, life could expand without being confined by scarcity. Cells that learned to use oxygen thrived. They grew larger, more complex, more daring. Inside their tiny structures, the first hints of something extraordinary began to take shape. These new oxygen-breathing organisms had discovered a revolution at the molecular level. They had evolved internal engines, tiny compartments that could harvest oxygen and use it to unlock far more energy than fermentation or chemical feeding ever could. Each breath of oxygen allowed them to generate strength enough to divide faster, move farther, and adapt more quickly. It was the start of aerobic life, and with it came the first whisper of everything that would one day follow: motion, growth, thought. Still, the world was fragile. The air was thin, the oxygen levels modest, the balance precarious. Too much oxygen could trigger fire. Too little could send life retreating back into the shadows of the ocean floor. But the planet, as if learning patience from its own long journey, adjusted. Volcanoes breathed carbon dioxide, balancing what the microbes consumed. Rain drew gases into the sea and back again. Earth had finally found a rhythm, a slow exchange between air, water, and stone that kept the balance steady enough for life to persist. If you could stand on a shore during this age, you would feel the difference in every breath, even if you could not yet see it. The air would have a faint metallic scent, a purity to it, cool and sharp. The sky would be clear and pale by day, brilliant with stars by night. The clouds would drift higher, lighter than before, no longer weighed down by methane and haze. And beneath that sky, the oceans would shimmer with the new colors of life: green from the photosynthetic mats, golden from bacterial blooms, streaked with the silver of reflected light. Everywhere, the world was experimenting. Life was no longer content to remain simple. The abundance of energy from oxygen meant that cells could afford to specialize. Some grew protective walls, others formed partnerships, merging into complex symbiotic systems. One cell absorbed another, and instead of consuming it, began to cooperate with it. Within that cooperation, something miraculous happened. The absorbed cell became the ancestor of mitochondria, the tiny organelles that power every complex organism alive today. It's difficult to express how profound that moment was, the union of two separate beings into one shared existence. It was the biological equivalent of fire being tamed or a spark being given purpose. The first true cells with mitochondria could use oxygen with stunning efficiency, transforming it into energy with elegance and precision. From that point on, the story of life accelerated. Complexity had found its foundation, and all of it depended on that breathable air, the thin, invisible veil of oxygen that wrapped the planet like a promise. Without it, no creature would ever run, no bird would fly, no flame would burn, no mind would think. It is easy, in the comfort of the present, to forget how improbable that balance really is. Oxygen makes up just a fraction of our atmosphere, and yet that fraction defines everything. A little more, and the planet would ignite in wild combustion. A little less, and complex life could never have taken hold. The Earth lives on a razor's edge of balance, maintained by the same processes that began in those ancient seas. The breathable air also brought with it an invisible gift: ozone. As oxygen filled the sky, some of it was transformed by sunlight into a shield, a thin layer of ozone that formed high above the surface, protecting the world from the harsh ultraviolet rays of the sun. Before ozone, radiation bombarded the surface, limiting life to the depths of the ocean. With it, the upper waters and even the barren rocks of the continents became safe. The Earth had finally made its own shelter. The stage was being set for life to step out of the sea and into the open air. But that moment was still far in the future. For now, the miracle was simply that the air could be breathed at all. Even the wind itself must have sounded different in this new world. It no longer hissed through thick gases or howled through sulphurous clouds. It moved cleanly, smoothly, carrying the first true breeze. Perhaps it carried the scent of the ocean, or the faint hint of iron-rich dust from the continents. Perhaps it even carried sound differently, softer and clearer, now that the air had thinned to something resembling what we know. The planet had become, for the first time, a place where breath was possible. The chemistry of survival had become the rhythm of respiration. Every wave that crashed on the shore, every gust of wind that swept across the land, was part of the same circulation: oxygen released, carbon drawn down, life continuing its slow inhale and exhale across ages. It is worth pausing to consider the strangeness of it all. The same element that would one day fill the lungs of animals, fuel the fires of civilization, and rust the iron of our cities began as waste. Oxygen was not created for us. It was an accident, a byproduct of the simplest forms of life doing what they needed to survive. Yet that accident became the foundation of everything. The planet's greatest gift was not planned, it was emergent. The Earth, through the quiet persistence of microbes, made a world that could breathe. When you take a deep breath now, somewhere in that air are molecules that once passed through those first oceans, through the lungs of dinosaurs, through the leaves of forests long turned to coal. It is the same oxygen, endlessly recycled, endlessly renewed. The miracle was not that the planet created air once, but that it never stopped doing so. Every sunrise, every photosynthetic leaf, every wave stirred by the wind continues that same work. The world breathes through all its living parts, and we are only one more expression of that breath. The breathable miracle was not just the creation of air, it was the beginning of connection. From that point forward, life would share one atmosphere, one circulation, one invisible link, binding everything together. Every creature, every plant, every human who ever lived would draw from the same well. The air would become the common language of existence, spoken silently through respiration. And as the sun set over that young world for the first time in its new blue sky, the planet glowed with the faint warmth of equilibrium. The long freeze was over. The air was alive. The oceans shimmered beneath a canopy of oxygen and light. The Earth, at last, was ready to host a future that could breathe. 8. The Great Awakening of Cells. The story of oxygen, up to this point, had been a story of chemistry, of gases and minerals, of slow reactions unfolding over unimaginable stretches of time. But now, the stage was ready for something far more intricate. With oxygen in the air and in the seas, the world began to shift from a planet of reactions to a planet of relationships. What emerged next was one of the most astonishing transformations in the history of life: the awakening of cells into something new, something greater than themselves. It began quietly, in the depths of the ocean, where light faded and heat from the Earth's interior still pulsed through vents in the crust. The waters there were rich with minerals and ancient microbes, some that thrived on oxygen, some that avoided it, and some that lived in the narrow border between. It was in those borderlands, where oxygen brushed against the chemistry of the old world, that life discovered partnership. For billions of years, single cells had ruled the Earth. They lived alone, competing for energy, duplicating endlessly, adapting in tiny increments. Each cell carried its own instructions, its own chemistry, its own small world within. But oxygen changed the rules. It was powerful and dangerous, both sustenance and poison. Many cells struggled to control it, to use it without being destroyed. Somewhere in that struggle, something extraordinary happened. A larger cell, one of the primitive ancestors of what we now call eukaryotes, engulfed a smaller one not to consume it, but to live with it. The smaller cell, a simple bacterium capable of using oxygen efficiently, found safety within the larger one. The larger cell, in turn, found in its new resident a source of energy unlike anything it had ever known. Together, they formed a partnership that would change everything. The smaller cell became what we now call a mitochondrion, the tiny powerhouse inside every complex cell, the organ that breathes for us all. It's hard to overstate how unlikely this moment was. Two separate forms of life merged, not in violence, but in cooperation. Instead of one destroying the other, they fused into a single being, each dependent on the other for survival. It was the first great act of biological trust, the moment when individuality became community. From that partnership came all complex life, every plant, every animal, every human being. The mitochondrion took the oxygen that once poisoned the seas and turned it into energy, channeling its reactive power into a controlled fire within the cell. It was the first time that life learned to manage combustion, to take something that could destroy it and use it for growth. Each breath of oxygen became a spark of life inside the new cells, a pulse of energy driving their processes forward. For the first time, life could do more than merely survive. It could expand, diversify, and imagine complexity. As these new eukaryotic cells spread through the oceans, the world began to quicken. Their energy allowed them to grow larger and to contain more intricate structures. They developed internal compartments, each performing a specific task. Some stored information, others managed proteins or nutrients. The first true nuclei formed enclosures for genetic material, safe from the chaos of the cytoplasm. With that separation came stability and control, a kind of internal order that had never existed before. It was as though life had built itself a mind, not consciousness as we know it, but an awareness of structure, a coordination of purpose. Within those tiny walls of the nucleus, DNA could be protected, repaired, and refined. Evolution, once slow and blunt, began to accelerate. Mistakes could be corrected. Instructions could be copied more precisely. The machinery of life grew sophisticated. The planet that had once belonged to simple, single-celled drifters was now the domain of beings with layers, compartments, and systems. The ocean must have shimmered with their presence, billions of new cells drifting in slow, luminous clouds. Under the sunlight that now reached the shallows, these organisms glowed faintly green and gold, feeding on light and oxygen. Some of them began to form colonies, clusters of cells bound together by thin films of sugar or protein. They communicated in chemical whispers, coordinating their movements, sharing nutrients. They had discovered cooperation. From these humble beginnings, the first multicellular life would eventually arise. But even before that, the single eukaryotic cells had become living worlds of their own. Within them, tiny mitochondria hummed constantly, converting oxygen into the pulse of energy that sustained them. Each cell was both factory and organism, both individual and community. The Great Awakening of cells was not just an event in biology, it was a shift in the meaning of existence itself. If you could somehow magnify one of those cells to the size of a house, you would see a world of motion inside. Rivers of fluid carrying molecules like cargo ships, filaments forming scaffolds, bending and flexing like muscles. Nuclei glowing softly, filled with spiraling threads of DNA, blueprints of life encoded in molecules so small they could carry entire futures in their patterns. And scattered throughout, countless mitochondria, each one flickering like a lantern, consuming oxygen, releasing energy, keeping the entire organism alive. The first eukaryotic cells were pioneers of complexity, but they were also record keepers. Inside their genes lay the story of everything that came before the microbes that rusted the seas, the cyanobacteria that filled the air, the survivors of the long freeze. Each generation carried those memories forward in its code, an unbroken thread stretching from the first sparks of life to the world that was now awakening. Oxygen had done something profound. It had linked time to energy. Before oxygen, evolution was glacially slow, limited by the energy that could be squeezed from chemistry alone. After oxygen, the pace of change quickened. Energy flowed freely, powering mutations, growth, and adaptation. Life began to experiment in ways it never had before. Structures that were once impossible became real skeletons of calcium, shells of silica, pigments that captured light in dazzling new ways. The Earth was preparing for the Cambrian explosion, though that great burst of diversity was still far in the future. For now, it was enough that life had found within itself the ability to breathe. The awakening of cells also brought with it a new kind of death. Oxygen, though essential, was still dangerous. It damaged molecules, burned delicate membranes, and aged the very cells it sustained. But death, too, became part of the balance. Cells learned to manage it, to recycle their components, to use decay as part of creation. The same molecule that gave them life also gave them purpose. It was as if the universe had introduced a kind of rhythm, birth and breakdown, inhale and exhale, all governed by the chemistry of air. As eukaryotic life spread, the oceans became richer, more dynamic. The very texture of the water changed. Oxygen dissolved into it, reaching depths it had never touched before. Nutrients cycled faster, ecosystems formed in miniature, and evolution danced through the currents. Life was no longer just a passenger on the planet, it was becoming an architect. If you were to close your eyes and listen to that time, you might imagine the faint crackle of chemistry echoing through the sea, the sound of energy flowing, of tiny engines humming in the dark. The cells, though silent to us, were singing the first song of complexity, their movements creating the pulse that would one day give rise to hearts, lungs, and thought. Every living thing that would ever breathe owed its existence to that chorus of cells learning to share oxygen. In that great awakening, the Earth became more than a place where life happened. It became a living system, connected from the smallest molecule to the largest wave. The atmosphere, the oceans, and the cells within them were now part of the same cycle. The planet had learned not only to breathe, but to think in patterns, to evolve with intention written in chemistry. And from that awakening, a promise was born. The promise that life could be more than survival, that it could reach for beauty, structure, and awareness. All of it powered by the same breath that still fills the air today, the same oxygen that turned a quiet, rusting planet into a world alive with color and thought. The cells had awakened, and through them, the Earth had begun to dream. 9. Colors of a new world. When the air finally cleared and the seas grew calm again, the Earth entered one of its most enchanting transformations. The world that had once been cast in muted tones of red and grey began to bloom with color. It happened not with the suddenness of dawn, but with the slow, patient rhythm that the planet always favored. Over millions of years, light began to scatter differently. Pigments began to form, and for the first time, the Earth started to look alive. It was not only a biological revolution, but also an aesthetic one, the first time nature painted with its own hand. The atmosphere, now rich with oxygen and nitrogen, had become thin and clear enough for sunlight to reach the surface in full spectrum. Before, the world had been filtered through haze, tinted by methane and volcanic gases. The sky had been orange or brown, the oceans greenish and opaque. But as the air transformed, the color blue began to take hold. Blue light, scattered most easily by the newly oxygenated atmosphere, filled the sky. From space, the planet would have gleamed azure for the first time. The oceans, now reflecting that sky, deepened into shades of sapphire and turquoise. The world had found its palette. Under those shimmering waters, life responded. The new eukaryotic cells, those intricate partnerships that had learned to use oxygen, were beginning to explore light itself. They developed pigments, molecules that could absorb sunlight and transform it into energy. Chlorophyll, the most famous of them, became the green signature of this new age. But there were others too, carotenoids of orange and yellow, phycobilins of deep red and blue. The seas became a living canvas, their colours shifting with the rise and fall of microbial blooms. If you could have hovered above those ancient oceans, you might have seen patterns forming across the water's surface, swirls of emerald and gold, ribbons of crimson light reflecting the pigments below. Each colour was a story, a strategy, a new form of survival. Green cells absorbed one wavelength of light, red cells another, each adapting to its own depth and region of the sea. The shallows glowed differently from the depths, and the world began to shimmer with diversity. For the first time, sunlight wasn't just warmth, it was language. Life had learned to communicate with light, to use it, store it, and even express it. Pigments became tools, but they also became the first expressions of beauty. Nature, without knowing it, had begun to paint itself. The formation of pigments was more than visual, it was chemical poetry. Each molecule of chlorophyll captured photons, releasing electrons in tiny bursts of energy. That energy powered photosynthesis, the ancient process that kept the air filled with oxygen. But these pigments also had another effect. They made the world visible. The interaction between sunlight, water, and pigment turned the Earth into something it had never been before, a place of reflection and radiance. The color green, in particular, was everywhere. The microbial mats that once coated rocks and sands began to glow faintly with it. Colonies of photosynthetic algae spread through shallow seas, catching light and breathing out more oxygen. The green shimmer that rolled across the planet's coastlines was a sign of renewal, a symbol that life had not only survived but flourished. As oxygen continued to build, the seas themselves changed hue. The iron that had once stained them red was gone, settled into the seafloor as stone. The waters cleared, becoming translucent and blue. The sunlight that reached through them danced across sediment and organisms alike, creating patterns of light and shadow that had never existed before. The world was learning texture, and with texture came contrast. Colours stood out against one another, the dark basalt of oceanic crust against the brightness of algae, the white of carbonate sands against the blues and greens of life above. The planet, for the first time, was beautiful not only in its function but in its appearance. The same processes that sustained life also created art. As eukaryotic cells became more complex, they began to assemble into colonies and filaments. Some of these developed specialized pigments for protection against the sun's ultraviolet rays. These pigments, reds, purples, browns, added new shades to the world's palette. The ocean floors were dotted with life in 1,000 tiny hues, each adapted to a slightly different intensity of light. In some places, microbial carpets would have looked like living mosaics, slowly rippling with the motion of currents. The oxygen-rich skies brought another change too: fire. For the first time in history, the Earth had air that could burn. Lightning strikes on dry land now sparked flames that danced briefly across rocky surfaces or within pockets of dry organic matter. Fire became a new painter in the planetary palette, leaving behind traces of blackened carbon and orange flame. Though rare, these early fires would become essential later, part of the cycle that balanced carbon and oxygen, part of the rhythm of breathing for the planet itself. As the eukaryotic organisms multiplied, some of them began to explore different depths and environments. Pigments evolved not just for photosynthesis, but for communication. Some microbes began to glow faintly in the dark bioluminescence, another miracle born from oxygen chemistry. In the still waters of night, tiny points of blue and green light would flicker, like stars scattered across the ocean's surface. The planet was glowing from within. It's easy, from our perspective, to think of colour as decoration, as something extra. But for those ancient forms of life, colour was survival. Pigments protected cells from radiation, managed light energy, and signaled adaptation. The red tones absorbed the light that green cells couldn't. The purple pigments thrived where sunlight was weak. The distribution of colour became the map of life's expansion. And yet, there is something quietly profound in imagining that this was also the first time the world truly looked alive. For billions of years, the planet had been active, but barren in its appearance. Grey mountains, dark seas, dim skies. Now, it glowed with vibrancy. The colours were not merely the byproduct of life. They were the evidence of it. The arrival of colour was also the arrival of emotion, though not yet in the way we experience it. There was harmony in the balance of hues, rhythm in the waves of pigment. The world was learning complexity not just in structure, but in feeling. The same beauty that would one day inspire art and wonder was already unfolding silently in the oceans. The oxygen that filled the air had given light the power to reveal, and in doing so, it had given the universe something new to witness. The blue of Earth was unlike anything else in the solar system, a signal, a beacon, a signature of life. Even now, when we look up at the sky or gaze down from orbit, that colour tells the same story. This is a world that breathes. In time, those colours would expand beyond the oceans. They would spread to the land, to mosses, lichens, forests, and flowers. But in this early age, they belonged to the sea. The waves themselves carried them, stirring green foam and red tides. Each sunrise ignited the surface in gold, and each sunset turned it to violet. The light that returned to the world after the long freeze had not only warmed it, it had made it visible in ways that were deeply new. If you could have stood at the edge of one of those ancient shores, you might have felt the air, still crisp and young, moving softly across your face. You might have seen the faint shimmer of colours blending in the shallows, rippling with the tide. You would be standing in the first gallery ever made, where the artist was the planet itself and the medium was life. The colours of that new world were not just a reflection of sunlight, they were the first expression of existence learning to see itself. And in that shimmering light, the earth seemed to exhale with quiet satisfaction. After eons of darkness and chaos, it had found balance. After the poison and the freeze, it had found beauty. The oceans glittered, the sky deepened, and for the first time in its long history, the planet looked alive. The colours of that age were more than hues on a surface, they were the living breath of a world becoming aware of its own vitality. The first language of wonder, spoken not in words, but in light. 10. The first shadows of complexity. There is a quiet moment in Earth's story when simplicity begins to hesitate, when the endless repetition of single cells and silent seas gives way to something uncertain, something new. It is the moment when life begins to dream of complexity. It didn't happen suddenly, and it didn't happen with intention. It was a slow murmur beneath the waves, a faint stirring of organization, the first suggestion that life could be more than what it had always been. By this time, the oceans were alive with color and movement. Oxygen shimmered through every layer of water, diffusing light and energy into places that had once been dark and still. The eukaryotic cells that had learned to host mitochondria were thriving. They were stronger, more efficient, capable of feats their ancestors could never have imagined. They carried within them the power to harness oxygen, to use it as an endless source of energy. And with that power came potential, the possibility of building something greater. At first, the difference between the new and the old would have been impossible to see. The early single-celled organisms still floated alone, dividing endlessly in the current. But within some of them, something had changed. They began to stick together after dividing, forming small colonies, temporary clusters that worked as one. These were not yet true multicellular organisms, but they were something in between, communities of cells sharing resources, coordinating their movements, responding together to the world around them. It was cooperation, fragile and experimental, and it was the first step toward everything that would one day walk, fly, or think. Inside each of these colonies, specialization began to appear. A few cells focused on movement, beating tiny flagella to propel the group forward. Others focused on gathering nutrients or processing light. For the first time, life was dividing its labor. It was an innovation that changed everything. When energy became abundant, efficiency became possible, and when efficiency appeared, complexity followed. The world at that time must have been breathtaking in its strangeness. Under the light of a newly blue sky, the oceans glowed with ribbons of color, dense mats of green, gold, and crimson drifting in slow currents. The continents, still barren and silent, were bordered by tidal flats where microbial films clung to rock and mud, sparkling faintly in the sun. The air, though breathable, was still sharp and clean, untouched by forests or decay. Everything smelled of minerals and salt, the scent of a planet still young and unburdened. If you could stand on one of those empty shores, you might have seen nothing alive at first glance. But under the surface, life was busy with its experiments. Tiny colonies were forming sheets and filaments, branching in delicate patterns like lace. They were early blueprints for the forms that would come later: corals, kelp, and tissues. Each filament was a negotiation between independence and unity. How much could a cell give up for the good of the group? How far could cooperation stretch before individuality broke? Those questions, unconscious yet fundamental, guided evolution for millions of years. In every drop of seawater, trillions of cells were testing boundaries. Some remained solitary, thriving in freedom. Others joined colonies, finding safety in numbers but losing part of their autonomy. Out of that balance between solitude and connection, the first true multicellular organisms emerged. They were simple, soft-bodied creatures made of repeating cells, with no bones, no organs, no eyes. Yet they represented something extraordinary. the beginning of structure. With structure came time. A single-celled organism could live, divide, and die in a matter of hours. But a multicellular creature required patience. It had to grow, to heal, to coordinate. For the first time, life stretched itself across longer spans of experience. Birth and death became more complex. The life of one cell was no longer the life of the whole. Individuals could now live within something larger than themselves. It was the first glimpse of mortality as we know it, and the first whisper of continuity beyond it. The oceans filled with these early forms, sponges, colonies of algae, filaments of cyanobacteria, intertwined with eukaryotic partners. They drifted in the current, soft and translucent, capturing light and nutrients. Some grew into sheets that waved gently with the tide, anchored by simple holdfasts to the sea floor. Others floated freely, glowing faintly in the upper waters where sunlight was strongest. These were the ancestors of plants and animals, of coral and jellyfish, of us. At the same time, the earth itself was changing in rhythm with them. The oxygen in the air reached new levels, stabilizing the climate and deepening the ozone layer. The sunlight became less harsh, filtered gently through the sky's protective veil. Rain fell in predictable cycles, carving rivers into the continents. The planet was finding its equilibrium, and in that balance, life found room to grow. The seas became ecosystems, rather than just collections of organisms. Food chains began to form, microbes feeding on sunlight, others feeding on those microbes, energy flowing upward in a web of exchange. Predation appeared for the first time, a subtle but monumental shift. To eat and to be eaten introduced new pressures, new possibilities. Life was no longer only about survival. It was about adaptation, about speed, defense, and awareness. The first shadow of conflict had entered the story, but so had the first glimmer of evolution's brilliance. It was during this period, often called the prelude to the Cambrian explosion, that the foundations of modern life were set. Cells developed communication systems, chemical signals that allowed them to coordinate in astonishing detail. Some cells began to sense changes in light, in temperature, in the presence of other organisms. The first sensory abilities were born, tiny sparks of perception in a vast, unseeing world. The ancestors of sight, touch, and awareness had begun to evolve, and yet, despite all these changes, the pace remained slow. Millions of years would pass between each innovation. The earth was patient. It had always been patient. The sea carried its quiet symphonies of life, growing richer and more intricate with every turn of the tide. The oxygen levels continued to climb, giving these new organisms the energy to evolve in directions never before possible. From the silence of chemistry, the planet was beginning to hum. The soft-bodied creatures drifting through the oceans were no longer just chemical reactions. They were patterns, systems, almost like thoughts forming in the mind of the earth itself. The world was awakening in layers, complexity building upon complexity, each step a continuation of the last. Imagine that world for a moment, the endless expanse of ocean, clear and luminous under the blue sky. The waves moving gently, their crests glowing with scattered sunlight. Below the surface, veils of life swaying like curtains of colour, each movement an echo of ancient tides. There was no sound but the pulse of water, no shadow but the one cast by the turning of the sun. And within that stillness, the first true multicellular organisms were living, breathing, dividing, and dying, unaware that they had begun the long path toward consciousness. What was once chemistry had become biology, and what was once biology was now on the edge of emotion. The line between living and feeling was still invisible, but it had been drawn. Oxygen had powered the change, feeding not only metabolism, but imagination, in its most primitive form, the ability to sense, to respond, to connect. This was the first shadow of complexity, the soft awakening that would one day lead to eyes opening, to hearts beating, to minds reflecting on their own existence. But for now, it was enough that the seas were full and the light was kind. The world had survived its fires and its ice, its poisons and its storms. Now, it was learning how to live with grace. The first shadows of complexity were not loud or visible. They were whispers beneath the waves, gestures between cells, murmurs of connection that would one day become the symphonies of evolution. The Earth, for the first time, was not just alive, it was becoming aware. 11. The Great Chain Reaction. The story of life has always been one of cause and consequence, each change setting another into motion, like ripples spreading from a single drop of water. When oxygen entered the atmosphere and the first complex cells emerged, it wasn't a simple event. It was the beginning of a chain reaction that would echo through every rock, ocean, and living thing that followed. What began as a chemical shift in the air became the architecture of everything that breathes, the pulse that would carry the planet from stillness into motion. By this time, the Earth was no longer young, but it was still learning how to be alive. The seas shimmered with diversity, thick with algae and microbial life that fed on sunlight. The continents, though mostly barren, had begun to change beneath the influence of oxygen and water. Rain fell differently now. It was cleaner, less acidic. It carried minerals from the highlands into the sea, feeding blooms of green life that painted the shallows in color. The world had entered a cycle, a rhythm of exchange between sky, land, and ocean. Each part of the planet fed into the next, and for the first time, the Earth began to resemble an organism in itself, a body with circulation, respiration, and heartbeat. The air was the bloodstream, the water, the veins, the continents, the bones, and life. Life was the pulse that kept it all moving. The oxygen in the atmosphere didn't just sustain life, it reshaped the planet's chemistry. The surface of the Earth began to weather differently. Rocks that had once been stable under anoxic skies now crumbled and rusted in the presence of air. Iron bled from stones, turning rivers red. Mountains slowly softened under the touch of time and rain. In this new balance, soil began to form a substance that had never truly existed before. Tiny fragments of mineral mixed with organic matter, creating the first fertile layers of land. The foundation of future forests was already being laid, long before the first root ever reached for the ground. Meanwhile, in the oceans, oxygen allowed for new forms of life that could move faster and grow larger. Metabolism accelerated, cells became specialized, and creatures began to interact in complex ways. Some fed, some fled, some hid in shadows, while others chased the light. Energy flowed upward through these interactions, from sunlight to microbe, from microbe to predator, and so on. The first ecosystems were forming a delicate balance of giving and taking, of living and dying, that would come to define every era that followed. It is humbling to realize that this intricate web of existence, all of it began with something as small as oxygen meeting sunlight. The Great Chain Reaction was not just biological, it was geological, atmospheric, even cosmic. The planet's magnetic field stabilized as its molten core cooled, shielding the surface from solar winds. The ozone layer thickened, protecting fragile life from ultraviolet radiation. And deep underground, the oxygen that seeped through cracks and fissures reacted with minerals, changing the very chemistry of the mantle. The Earth, in every layer, was transforming. As the atmosphere continued to shift, the temperature stabilized further. The greenhouse gases that had once choked the planet were balanced by the oxygen-driven carbon cycle. Photosynthesis consumed carbon dioxide, locking it away in organic matter and limestone. Volcanic eruptions released it again, renewing the balance. The planet had found a rhythm, a living equilibrium that would persist for hundreds of millions of years. Each breath of oxygen, each ray of sunlight, each pulse of volcanic energy contributed to that rhythm. The Earth was learning to sustain itself, not through control, but through harmony. And yet, this harmony was never static. Every improvement brought with it new instability. The same oxygen that allowed complex life to thrive also made the planet more flammable. Fire, once impossible, now danced across dry land. Lightning struck, igniting organic matter into flame. The first fires would have been small and scattered, but they were significant. They created new cycles of destruction and renewal. Ash from those fires would feed the soil, enriching it with nutrients. Even catastrophe had become part of creation. In this balance of opposites, growth and decay, order and chaos, the Earth found a strange kind of wisdom. Life didn't resist change, it used it. Every extinction, every upheaval became the groundwork for something new. The oxygen that had once wiped out ancient species now sustained the descendants that replaced them. It was a pattern that would repeat through every chapter of Earth's story, each ending feeding a beginning. As multicellular organisms grew larger and more diverse, they began to influence the environment around them in new ways. The movement of living things stirred sediments, circulated oxygen deeper into the seas, and altered the chemistry of the water. The creatures of the ocean were no longer just products of the planet, they were shaping it in return. The Great Chain Reaction had become self-aware, not in thought, but in effect. The world had entered an age where life itself was a geological force. The seafloor, once quiet and untouched, became busy with activity. Burrowing organisms disturbed the sediment, allowing oxygen to penetrate deeper into the mud. This seemingly small behavior changed everything. It altered nutrient cycles, affected microbial life, and made ecosystems more dynamic. The Earth was becoming collaborative, a network of interlocking feedback loops that connected everything from the deepest trench to the highest cloud. Imagine it. Waves rolling gently over shallow seas, sunlight breaking into beams that shimmered through green water. Beneath that light, forms drifted and pulsed, tiny translucent shapes moving in unison. The current carried them together, then apart, as though the ocean itself were breathing. In those waters, the chemistry of air and life continued its eternal conversation. Every inhalation of oxygen by one organism was matched by an exhalation of carbon dioxide from another. Every death nourished a future birth. It's easy to think of oxygen as a simple gas, but it had become something far more profound. It was connection. It was the medium through which life interacted not just with its surroundings, but with itself. Through oxygen, life became interdependent. One creature's breath became another's need. One generation's decay became the soil of the next. The entire planet was linked by invisible chains of exchange, bound together in one great exhalation. The Great Chain Reaction was also a chain of memory. Every cell carried within it the blueprint of its ancestors, the record of how to survive and adapt. And those blueprints were written in molecules shaped by oxygen's power, the DNA and proteins that relied on its chemistry to exist. The atmosphere, the ocean, and the genome were all connected by the same invisible thread. In time, this connection would lead to something extraordinary. The abundance of oxygen would make possible larger bodies, faster metabolisms, and nervous systems that could think, move, and feel. But at this point in the story, life was still in its adolescence, still growing into the vast energy it had been given. The planet itself was young enough to wonder what it might yet become. Every reaction that had started in the depths of the ocean, every molecule of oxygen that had drifted into the air, had led to this moment. The Great Chain Reaction was no longer just unfolding, it was accelerating. Evolution was gaining speed, feeding on the very energy that oxygen made possible. The groundwork had been laid for the next leap forward, one that would fill the seas with creatures that could swim, hunt, and sense the world around them. But for now, the world was content to hum quietly in its new equilibrium. The air shimmered, the ocean stirred, and the land waited. Every process, every element, every spark of life was part of one grand cycle, an unbroken conversation between matter and meaning. The Great Chain Reaction was not just the story of oxygen, it was the story of connection, of how one change can awaken an entire world. The Earth, alive and aware in its own way, continued to breathe in rhythm with the stars. The same balance that had begun with the smallest cell now stretched from the depths of the ocean to the edge of the atmosphere. The planet had found its voice, and it spoke softly, through wind and wave and breath, repeating the same ancient truth. Everything changes, and through that change, everything continues. 12. When skies turned blue, there was a moment, far back in time, when the Earth looked up for the first time through its own new atmosphere and saw the colour of itself. Before that, the skies had been heavy bronze with methane, dimmed by haze, wrapped in the dull orange of volcanic breath. The air was thick, not yet the transparent window we know today. But as oxygen spread and balanced with nitrogen, something extraordinary happened. The skies turned blue. It was not just a shift in colour, It was the unveiling of clarity. For the first time, sunlight could move freely through the air, scattering and dancing, painting the heavens in hues of calm. The planet, for the first time in billions of years, could see the light of its own star without distortion. The blueness of the sky wasn't an instant transformation. It came slowly, like a dawn that lasted for eons. The more oxygen filled the air, the less room there was for methane and carbon haze. The atmosphere thinned and cleared, the chemistry of scattering began to change, and wavelengths of shorter light blue light were dispersed in every direction. The world grew brighter, softer, more open. It was as though the planet had exhaled its last breath of confusion and finally settled into its own rhythm of transparency. Under this new sky, light behaved differently. The warmth that once barely reached the ground now soaked the surface more evenly. Shadows softened. The sea, now free of rust and murk, reflected the sky above it. The earth became a mirror of itself. Blue above, blue below, a sphere of living light. For the first time, space beyond the planet could have seen what we see today, a world glowing with oceans and clouds, gleaming softly in the sun. The blue sky did more than change how the planet looked. It changed how it lived. Sunlight now reached deeper into the seas, illuminating waters that had long been cloaked in gloom. Energy poured into the upper layers of the ocean, feeding new blooms of algae and photosynthetic life. The photosynthesizers, in turn, released even more oxygen, reinforcing the cycle. It was a loop of light and breath. The more the earth cleared, the more it could breathe, and the more it breathed, the clearer it became. This feedback of brightness became the foundation of stability, a harmony between air and light that has continued ever since. If you had been able to stand on the planet then, it might have been disorienting. The light was pure in a way it had never been before. The air was invisible, its density transformed. The clouds, white now, not stained by chemical fog, moved gently across a canvas of blue, casting drifting shadows on the open seas. The wind carried new smells, the faint salt of living oceans, the mineral scent of freshly oxidized rock. The atmosphere, newly open and breathable, had become both a shield and a sanctuary. The formation of the ozone layer was one of the quiet miracles that made this moment possible. As oxygen accumulated in the upper reaches of the atmosphere, ultraviolet radiation from the sun split some of the molecules apart, allowing them to reform into ozone, 3 atoms of oxygen bound together. That ozone gathered in a thin layer high above the world, absorbing harmful radiation that had once burned the surface bare. It was a fragile veil, invisible and silent, but it was the planet's first true protection. With it, life could rise closer to the surface, daring to meet the sunlight directly. The Earth, for the first time, could hold its own against the star that birthed it. Under this protection, evolution quickened. The oceans grew alive with movement. Eukaryotic cells began to join in more intricate ways, weaving tissues, forming shapes that were no longer just accidental colonies, but living structures with purpose. Soft-bodied organisms appeared, translucent and strange, drifting in the open water. The oxygen they consumed powered their motion, their growth, their capacity to evolve. The clarity of the air and the depth of the blue above them meant something profound. The energy of the sun had become available like never before. Light had always been the planet's most faithful sculptor, and now it had full access to its canvas. The colors of life deepened. Greens became richer. Reds and purples, once rare, spread through pigment-bearing microbes that thrived under the new clarity. The sky's blue intensified their contrast, turning the world into a masterpiece of subtle balance. Every sunrise was an act of chemistry. Every sunset, a performance of scattering. Even the night changed. With the haze gone, the stars became visible again. Points of light scattered across a darkness so deep it almost seemed infinite. The universe itself was now reflected in the eyes of the planet. The beauty of the blue sky carried within it a quiet irony. Oxygen, the very element that made it possible, was still a double-edged force. It burned as easily as it sustained. It aged and corroded everything it touched. The same process that let organisms breathe also caused their decay. The air had become both creator and destroyer. and life was learning to balance between those two roles. But it was in that balance that resilience formed. Every breath, every cell, every adaptation was an act of harmony with a dangerous and precious element. The presence of a blue sky also meant that heat was distributed differently. The planet cooled at night, warmed gently by day. Seasons began to stabilize. The cycles of rain and evaporation became more predictable, setting the stage for the rhythms that would one day shape forests, deserts, and migration. The color of the sky was not just an aesthetic, it was a sign of balance, a visual manifestation of chemistry at peace. If you were to look at the Earth from afar during this time, you would see something breathtaking. A thin halo of atmosphere glowing faintly around the planet's curve, light scattering through it like silk. The oceans, vast and deep, reflecting that halo in trembling ripples. White clouds swirling slowly, softening the edges of continents still barren but beginning to show the first hints of erosion that would one day become soil. It was the same view that astronauts would marvel at billions of years later, a view that makes even now feel ancient and eternal. The blue sky became the backdrop for everything that would follow, for weather, for climate, for life itself. It allowed the planet to moderate its heat, to shield itself, to nurture. It gave color to memory, to meaning, to existence. And in that endless dome of air, the first whispers of something more began to emerge. A rhythm, a pulse, a sense of connection between the living and the luminous. When the skies turned blue, the Earth gained not only light, but vision. For the first time, life could see beyond the immediate, could orient itself to the sun, could move and grow in deliberate patterns. The blue of the atmosphere guided the first migrations of plankton and algae toward light. It defined the cycle of day and night, the rise and fall of photosynthesis, the choreography of evolution itself. Even now, that same blue governs our sense of peace. It calms, it expands, it reminds us of space and depth. Perhaps that is because our species carries the memory of this moment deep within its bones. The blue sky was the first color our planet ever truly owned, the first sign that the world had found balance between light and air. When we look upward and feel that strange, wordless comfort, we are remembering what it felt like when the Earth first breathed freely. The turning of the skies to blue was not just the triumph of oxygen, it was the planet's awakening into vision. From that moment onward, light and life became inseparable. Every sunrise since then has been a continuation of that first unveiling, every breath a reflection of that first exhalation of air. The Earth, once blind and shrouded in haze, had finally opened its eyes, and in doing so, had given the universe its first clear view of itself. 13. Beneath the blue horizon, beneath the newly cleared sky, under that soft, endless blue that had only recently appeared, life was unfolding in quiet complexity. The Earth, still mostly ocean, was becoming a living network of energy and movement. The waves shimmered like mirrors, carrying sunlight down into depths that had never known illumination before. In those depths, the history of life was being rewritten, not through violence or sudden leaps, but through patience, the slow art of adaptation. Every current, every glimmer of light, every particle of oxygen carried the potential for transformation. The world had grown calmer. The violent chaos of volcanic eras was fading, and the balance between atmosphere and ocean had steadied into rhythm. Days and nights now meant something. Sunlight rose, crossed the sky, and fell again with reliable grace. The temperature ebbed and flowed, creating cycles that guided the earliest behaviors of life. The tides, pulled by the moon, breathed in and out along the coastlines, whispering to the colonies of algae and microbial mats clinging to the rocks. The ocean was not just a body of water anymore, it was a living pulse, and within its depths, the first true ecosystems were beginning to take shape. The organisms of this age were still simple by modern standards, but they were astonishing in their elegance. Sheets of cyanobacteria draped the seafloor like living carpets, shimmering faintly in green and blue. Filaments of algae rose from shallow sediments, swaying with the motion of the waves. Tiny, translucent organisms drifted through the water, feeding, dividing, and dying in endless succession. The Earth was beginning to hum with subtle complexity, each life form part of a system too vast to see but too precise to be coincidence. Oxygen was at the center of it all. The same element that had once brought ruin now acted as the breath of harmony. It fueled metabolism, powered growth, and linked every creature to the next through invisible exchange. Even in death, organisms released what others could use, keeping the balance unbroken. The ocean had become a mirror of the atmosphere, a vast circulation of chemistry and light. It was in this equilibrium that the stage for evolution's next act was being set. As the sunlight penetrated deeper into the sea, it revealed new layers of opportunity. Some organisms learned to capture light in unique ways, evolving pigments that allowed them to thrive where others could not. The blues and greens of shallow water gave way to reds and purples in the depths, each shade a solution to the problem of survival. Color was not just decoration anymore, it was strategy. Life was learning to shape itself around light, to use it as both nourishment and language. In these ancient seas, the first predators appeared. They were not yet hunters in the modern sense, but they were something new, organisms that consumed other organisms instead of relying solely on sunlight or chemistry. This shift was monumental. For the first time, life was feeding on life. It was a moment of both creation and danger, a spark that would ignite the complexity of ecosystems for billions of years to come. The ocean had become a place of interaction, of competition, of relationships. It was no longer a passive soup of life, it was alive with tension, exchange, and growth. Beneath the surface, change was constant but graceful. The currents carried nutrients across the globe, connecting distant regions through invisible threads of flow. Volcanic vents still erupted from the seafloor, releasing minerals and warmth into the darkness. Around those vents, new communities of life formed, creatures that did not need sunlight at all, drawing energy instead from the Earth's internal heat. They thrived where no light reached, proof that life could adapt not only to the gentle rhythm of the surface, but also to the raw power of the planet below. In those shadowed regions, where oxygen was scarce and water shimmered with heat, sulfur-fed organisms flourished. They built strange colonies of filaments and tubes, glowing faintly with bioluminescence. These deep-sea pioneers were the keepers of an older world, a reminder that life did not belong only to the light. Even as the blue skies transformed the planet above, the darkness below remained alive with mystery. The duality of light and dark defined this chapter of Earth's story. In the sunlit shallows, photosynthesis ruled, painting the waters with color and filling the air with oxygen. In the deep, darkness reigned, but it was not lifeless. The two worlds coexisted, linked by chemistry and current. Nutrients sank from above, feeding the organisms below. In turn, the waste of the deep was carried upward, recycled by the ocean's motion. The planet had achieved something profound: unity across difference. The surface and the depths, the light and the dark, were part of the same conversation. If one could stand on the seafloor, then if there were eyes to see, it would be a landscape of dreams. Pillars of rock, shaped by volcanic vents, stood like monuments, surrounded by shimmering plumes of mineral-rich water. Around them, mats of microbial life formed living tapestries that pulsed softly in the dim glow of bioluminescent creatures. Tiny, drifting forms moved like sparks, catching the faintest traces of light from above. It would have been a world of silence, yet filled with movement, a cathedral built not of stone, but of chemistry and breath. Above, the surface glittered with sunlight. The waves reflected the sky's deepening blue, and clouds drifted lazily across continents still bare. Rain fell, feeding rivers that carved through rock and returned to the sea. Each droplet carried minerals, the nutrients of future life, dissolving and redistributing the planet's essence. The water cycle had become more than weather, it was the great circulatory system of the world. The balance of oxygen between the ocean and the air shaped everything. When the surface waters grew too full of life, decomposition consumed oxygen faster than it could be replaced. The ocean would darken, parts of it suffocating in silence, yet the Earth always recovered. Over time, photosynthesis would return balance to the cycle, bringing oxygen back to the seas. This dance of abundance and collapse was the heartbeat of evolution, a slow rhythm of creation and renewal that never truly stopped. In those long epochs, the foundations for future complexity were being built invisibly. The ocean was perfecting its chemistry, the atmosphere was steadying its rhythm, and life was testing the boundaries of form. Some of the multicellular colonies began to develop symmetry, simple repetition that would one day evolve into recognizable shapes. Others began to communicate more efficiently, exchanging chemical signals that allowed them to act as one. Cooperation and conflict deepened side by side, and out of that tension came innovation. The planet beneath the blue horizon had found balance, but not permanence. Nothing on Earth was ever still for long. The continents were moving, slowly shifting their shapes beneath the sea. Volcanoes continued to breathe, adding new islands to the surface. Lightning still danced in the clouds, igniting small fires when it struck the dry edges of land. Every force on Earth, every movement, every reaction was part of the same grand continuity, the same chain of cause and renewal that had begun the moment oxygen first filled the air. If you could have floated just above the ocean then, feeling the warm breeze against your face, you might have sensed the enormity of it. The sky, clear and blue, the water, glimmering with life. The world, finally in tune with itself. The air would have carried a faint metallic scent, the echo of ancient chemistry still lingering, and beneath the waves, unseen but ever present, life would have been preparing its next great transformation. The blue horizon was not an end, it was a promise, a threshold between the past and everything that was yet to come. The seas that now glittered with color would soon give rise to forms that moved with purpose, creatures that sensed, responded, and interacted with the world in new ways. But for now, the Earth rested in its balance, breathing softly beneath its blue canopy. It had survived fire, ice, and poison. It had learned how to shine, how to breathe, and how to sustain. Beneath that vast horizon, the planet was still dreaming. Every current carried whispers of what would come next: coral reefs, forests, creatures with eyes and hearts. The blue above and the blue below were reflections of each other, infinite and calm. The Earth, newly alive and aware, floated in the quiet between transformation and destiny, waiting for life to take its next breath. 14. The quiet architects. In the stillness of the world beneath the blue skies, something remarkable was happening. Something so subtle that even if you could have watched the oceans with perfect vision, you might have missed it. While the waves sparkled under sunlight and microbial mats rippled along the shallows, life was beginning to build. Not in the way volcanoes build land or rivers carve valleys, but in a quieter, gentler manner. Microscopic organisms were becoming architects, reshaping the very surface of the planet grain by grain, breath by breath. The first builders of Earth's living world were not grand or complex. They were small, patient, and persistent. Cyanobacteria, those tireless masters of photosynthesis, continued to grow in mats that coated the ocean floor. Each layer they built trapped tiny particles of sediment, binding sand and mineral together until, over countless generations, they hardened into stone. These layered stones, stromatolites, were not just biological structures. They were the first monuments ever made by life, standing as living fossils of intention. Even today, in a few rare corners of the planet, you can still see them, breathing in light as they have done for billions of years. Each ripple of those ancient microbial communities told a story of time, measured differently, time not in days or seasons, but in eons. A single centimeter of growth could represent 1,000 years of persistence. The rhythm of their expansion followed the tides, the light, and the chemistry of the water. They were slow sculptors, shaping the seabed with patience that only the universe itself could understand. These stromatolites and microbial mats did more than build, they transformed. As they photosynthesized, they released oxygen, layer upon layer, into the water around them. Every bubble of gas that escaped from their mats drifted upward, joining the atmosphere, feeding the great blue dome that had only recently become clear. Their work was invisible on the scale of a day, but across the span of centuries, they were changing everything. They were weaving the foundation for a planet that could one day sustain forests, animals, and minds. It's strange to think that the greatest engineers in Earth's history had no awareness of their work. They did not plan or foresee the outcome of their persistence. Yet their collective efforts shaped the world as surely as mountains rising or rivers flowing. They were the quiet architects of balance, transforming sunlight into structure and chemistry into permanence. Through them, life had learned how to leave an imprint that would outlast its creators. As oxygen levels continued to climb, other forms of life began to take advantage of this new abundance. In the shallows, eukaryotic algae flourished, creating vast blooms that turned the sea's emerald under the sun. They too became builders, not of stone, but of atmosphere. Their work was invisible, yet it filled the world with breath. The air we inhale today still carries the legacy of their exhalations, molecules of oxygen born in those ancient waters, recycled through billions of generations. The ocean itself was becoming architecture. Tiny organisms known as foraminifera and radiolarians began to craft shells from minerals dissolved in the water. These shells were intricate, delicate, and endlessly varied spheres, spirals, lattices, and filigree patterns that seemed more like art than biology. Each one was a small cathedral of calcium or silica, constructed cell by cell in perfect proportion. When these creatures died, their shells sank, accumulating on the seafloor as vast deposits of sediment. Over millions of years, those deposits would turn to limestone and chert the bedrock of continents, the stone from which mountains would later rise. Through their quiet labor, these microscopic architects reshaped the boundaries between life and geology. The Earth's crust and its living surface became intertwined, each influencing the other. The rocks breathed through the oceans, and the oceans breathed through the sky. It was a cycle of building and dissolving, of creation and decay, so finely balanced that it could continue indefinitely. The beauty of this age lay not in its speed or drama, but in its endurance. Everything that lived, built, and died was part of a grand design that required no designer, only time, light, and patience. The patterns that formed in the sediments and shells were mathematical in their precision, almost musical in their repetition. Each structure was both functional and beautiful, each serving life while also leaving a record of it. If you could have drifted through those waters, watching the soft glow of sunlight filter through layers of plankton, you would have seen a world that seemed both alien and familiar. Beneath you, the seafloor was alive with texture mats, ridges, and domes formed by the slow accumulation of living matter. Around you, tiny organisms drifted like motes of light, each carrying within it the potential to build. The water itself shimmered with invisible construction, its chemistry shifting moment by moment as carbon turned to stone, as calcium became architecture. Even the silence of that time was creative. There were no fish, no birds, no forests to break the calm, yet the planet was busy with movement at the smallest scales. Every ripple of water carried suspended life. Every molecule was part of an exchange. It was a world of detail, a planet perfecting the art of subtlety before the arrival of grandeur. The quiet architects also began to influence the climate in ways they could never comprehend. By capturing carbon dioxide from the air and locking it into their shells and stones, they cooled the planet, keeping the balance between heat and cold. When their remains sank into the deep ocean, they carried that carbon with them, storing it for ages. It was an unintentional gift, a safeguard against chaos, one that would allow life to continue through cycles of ice and fire. In this way, the microscopic builders became the custodians of stability. They regulated the chemistry of air and ocean, maintaining a balance so delicate that even small changes could ripple across the planet. Theirs was a silent stewardship, an act of creation sustained by the simplest of needs: sunlight, minerals, and time. It's tempting to think of architecture as something that requires intelligence, design, or purpose. Yet here, in the deep past, it was instinct alone that shaped the first temples of stone. Each organism, following nothing more than the rhythm of survival, contributed to a structure that would endure beyond imagination. The reefs and sediments they created were the first memory of the planet, a physical record of life written in rock. Over time, these living structures grew vast. In some regions, reefs stretched for miles, rising slowly toward the surface like submerged continents. The light that touched their upper edges flickered through the water, casting shifting patterns on the life below. These reefs became sanctuaries for new organisms, providing shelter and food. Life had built its own foundation, and from that foundation, it would one day build the complexity of ecosystems. The oceans of this era were both builders and archives. Each new layer of sediment was a page, each shell a word. The Earth was writing its autobiography, and the language was geometry spirals, ridges, spheres, and domes repeating endlessly across the seafloor. To look upon it would be to glimpse the first art, the first architecture, the first sense of permanence that life had ever known. And so, beneath the tranquil blue skies, while no creature yet had eyes to see or hands to carve, the planet was already being shaped by intentionless artistry. The quiet architects, microbes, algae, foraminifera, radiolarians worked in unison, crafting a world that was both beautiful and resilient. They did not know they were building the bones of continents or the oxygen of future breath. They were simply living, and through living, they created. The world they left behind was not loud or dramatic, but it was enduring. Their reefs, shells, and stones became the foundation for everything that would follow, for coral, for limestone cliffs, for mountains that would one day hold the fossils of creatures that had yet to exist. Their work was the patient whisper beneath evolution's roar, the invisible hand that shaped the world long before thought or language ever arrived to name it. Under the soft blue of that ancient sky, the quiet architects continued their endless construction. Each sunrise was a beginning, each tide a continuation, and though none of them could ever have known it, their art was eternal, the breath of the planet captured in stone, the architecture of time itself. 15. The world begins to breathe together. By now, the Earth had settled into a rhythm so delicate it was almost musical. The air, the oceans, the stones, and the living things within them were no longer separate forces. They were movements in a single symphony. Each breath of oxygen, each ripple of tide, each pulse of sunlight echoed through the whole planet. The Great Oxidation had begun as a revolution of chemistry, but by this time it had become something far more profound: the unification of the Earth's systems into one living, breathing whole. The planet itself had become an organism, exhaling through forests that did not yet exist, inhaling through seas that shimmered with the labor of life too small to see. If you could have floated above that world then, you might have sensed its stillness from afar: blue oceans under a pale sky, vast continents barren and stony, clouds drifting lazily across an unbroken horizon. But beneath that calm surface, everything was in motion. The atmosphere circulated in great bands of wind, the ocean currents carried nutrients from the deep to the shallows, and volcanic heat rose from within the earth to feed the chemistry of the seas. Each motion was connected to another, each reaction a continuation of the last. It was the first time that everything air, water, rock, and life had moved in balance. Oxygen had made this balance possible, but it had also made it fragile. Too much oxygen, and the planet could burn. Too little, and it could suffocate. And yet, somehow, it stayed steady. The living things of the oceans acted as regulators, breathing out oxygen when it was needed, drawing it back through respiration when the balance tipped too far. Cyanobacteria still covered vast regions of the sea, but now they shared their waters with eukaryotic algae and other photosynthetic organisms, each playing its part in the great equilibrium. The ocean had become a mindless, perfect governor of its own breath. It is humbling to think that such balance arose not through intention, but through adaptation. The Earth had no overseer, no consciousness guiding its flow, and yet it seemed to act with wisdom. Every microbe, every molecule was responding to its environment, adjusting its chemistry, and through those adjustments, the planet itself found stability. The ocean breathed, and the air answered. The air cooled, and the water condensed. The clouds formed, and the rain fell, returning minerals to the sea. The cycle was infinite, seamless, alive. The continents were beginning to play a part too. Erosion, long dismissed as destruction, became creation. Rainfall, newly rich with oxygen, broke down rocks, releasing minerals that flowed into the oceans. Iron, phosphorus, and silica fed the plankton that filled the seas with life. Each drop of rain was both a sculptor and a messenger, carrying whispers from mountain to sea, from stone to cell. The first landscapes of interdependence were being drawn not in forests or grasslands, but in the chemistry between sky and stone. In the shallows, colonies of algae formed massive floating fields, stretching for kilometers. These blooms shifted with the tides, forming bright swaths of color visible from above. They absorbed sunlight, exhaled oxygen, and then slowly died, sinking back to the depths. Their remains became food for others, or sediments that would one day turn into rock. Even death, in this age, was a kind of recycling, one more movement in the planetary breath. The deep oceans, too, were alive with transformation. The oxygen that filtered downward allowed new organisms to thrive in places that had once been suffocating. Multicellular life began to explore the darkness, evolving structures and behaviors suited for survival in the quiet, cold. Tiny creatures developed the ability to move deliberately, propelling themselves with flagella or undulating bodies. They hunted, hid, and multiplied. For the first time, life was not only surviving, it was interacting in ways that created ecosystems of complexity. Everywhere you looked, the earth was forming connections. The gases of the air spoke to the minerals of the ground, which spoke to the waters of the sea, which spoke to the microbes of the deep. Nothing existed in isolation anymore. The planet had found a way to circulate its energy endlessly, ensuring that what was lost in one place was created in another. In this balance of exchange, there was a sense of purpose. Not the purpose of thought, but the purpose of continuation. If you could have stood on one of those early coastlines, your senses would have been filled with contrasts. The wind, cool and clean, carrying the faint metallic tang of oxygen. The sea, glistening under the sun, its surface alive with invisible respiration. The sound would have been faint but constant, the slow rush of waves, the hiss of air, the endless motion of a world exhaling. There would have been no trees to break the horizon, no grass beneath your feet, but everywhere you looked, there was life in motion, hidden and patient. Above it all, the blue sky stretched, brilliant and endless. The same scattering of light that colored the air also kept the planet warm enough for life to continue. The ozone shield, still thin but protective, absorbed the sun's most dangerous rays, allowing life to rise closer to the surface. Photosynthetic organisms flourished in this gentle glow, turning sunlight into structure, turning breath into being. The planet had become a cradle of renewal, each sunrise repeating the act of creation. The Great Oxidation had begun, as disaster a poison to the old forms of life. But here, in this calmer epoch, it had become a gift. Oxygen was no longer an intruder, it was the planet's heartbeat. Every molecule of it carried memory, having passed through countless generations of life before finding its way back into the air. Even now, when you breathe, you are inhaling that same inheritance, the breath of ancient seas, the exhalation of microbes that shape the sky. The air in your lungs has been here before, part of the same endless rhythm that began in those quiet oceans. The first reefs were beginning to rise now, built from the remains of the quiet architects who came before. Their stony skeletons formed ridges and mounds across the seabed, breaking waves, slowing currents, creating places of calm. These reefs became havens for life, safe zones in a vast, moving sea. Within them, early multicellular creatures thrived, adapting to the rhythms of the tides. In their shadows, smaller organisms hid, and in their crevices, chemistry continued its patient work. Life had begun to build its own architecture of safety, its first true homes. Above these underwater cities, the oxygen continued to pour into the atmosphere, and something extraordinary began to happen. The balance between oxygen and carbon dioxide reached a point where the planet's climate stabilized further. Temperatures evened out, allowing the oceans to remain liquid and the skies to remain gentle. For the first time in its long, chaotic history, Earth was peaceful, not lifelessly still, but dynamically calm. Every part of it worked in quiet cooperation, a harmony that would allow evolution to gather strength for its next great leap. There is something deeply moving in the thought of a world breathing as one. The air that rose from the oceans drifted across continents, fell as rain, and returned to the sea again. The water that evaporated from waves became clouds that cooled the mountains. The carbon exhaled by dying organisms became the stone that future generations would stand upon. Every exchange, every transformation, was part of the same continuous act of balance. The planet was not merely alive, it was aware in its own wordless way. And so, under that endless blue, Earth inhaled and exhaled, a single, living organism spread across billions of forms. The Great Oxidation had given the world breath, but now it had given it unity. The oceans shimmered with motion, the sky glowed with scattered light, the continents slept beneath their barren stones, waiting for life to come ashore. The planet was ready, the world had learned to breathe together, and in that unity lay the promise of everything that would follow the forests, the creatures, and one day, the beings that would look back at this deep history and call it beautiful. 16. The rise of movement. The seas were no longer quiet. For billions of years, life had drifted passively, carried by the slow rhythm of currents, the pull of the moon, and the steady flow of chemistry. But now, something subtle began to stir within that calm expanse, a restlessness, a hint of intention. In the clarity of the oxygenated waters, life discovered the first whispers of motion. It began not as swimming or walking or flight, but as a tremor, a ripple within a single cell that felt the difference between light and dark, between current and stillness. And that tremor, that microscopic pulse of awareness, changed everything. The rise of oxygen had made this new restlessness possible. With abundant energy available, life could afford to move. Until now, most organisms had lived in stillness, anchored to surfaces or floating wherever the water carried them. Movement was costly, it consumed energy, and before oxygen, there simply wasn't enough to spare, but oxygen was generous. It filled cells with power, igniting biochemical engines that could sustain activity far beyond anything the ancient anaerobes could have imagined. The planet's breath had given life not just energy, but the freedom to use it. At first, motion was a survival mechanism. Some cells began to twitch toward light, guided by faint pigments that sensed brightness. Others recoiled from harm, heat, acidity, or shadow. This ability to respond, to choose direction even in the simplest sense, was the beginning of agency. The ocean, once filled with drifters, was now awakening to pursuit and retreat. One organism moved to capture, another moved to escape. From that dance of attraction and avoidance, the first stories of interaction began to unfold. It must have been a mesmerizing sight, if eyes had yet existed to see it. Under the soft blue glow filtering through the upper layers of the ocean, billions of tiny beings pulsed, twitched, and spun in slow, graceful choreography. Threads of light seemed to shimmer through the water, catching on the transparent bodies of these pioneers of motion. The sea was no longer static, it was alive with rhythm, a ballet of microscopic swimmers tracing invisible paths through their liquid world. Somewhere in that dance, life found its first predators. Tiny multicellular creatures evolved not just the ability to move, but the will to chase. They sensed the chemical traces of others and followed them through the water, their movements growing faster and more deliberate. They devoured smaller, slower organisms, drawing strength from their remains. It was a quiet revolution, the invention of predation, and though it may sound cruel, it was also a spark of creativity. Predators forced prey to adapt, to hide, to flee, to innovate. And so evolution, which had moved at the pace of geology, began to accelerate. The rise of motion changed not just biology but the entire character of the ocean. For the first time, nutrients and energy were being moved intentionally, carried from one region to another by living beings. The flow of matter through the sea became more dynamic, more circular. What had once been a planet of chemical diffusion became one of biological exchange. Movement made the world more interconnected, more alive. These early swimmers were simple in form, soft-bodied, often gelatinous, translucent as mist. Their movements were graceful rather than powerful, relying on cilia or flagella to propel them forward in delicate spirals. Yet even in their simplicity, they were astonishingly efficient. Each flick of a cilium, each wave of a flagellum, was powered by the same chemical fire that oxygen had made possible. Every movement was an act of transformation. Sunlight turned to sugar, sugar turned to motion, motion turned to survival. Over time, movement became more than a necessity, it became expression. Some organisms began to drift in deliberate patterns, spiraling upward towards sunlight by day and sinking into darkness at night. Others formed colonies that pulsed in rhythm, moving as one body. There was a strange beauty to this new world, an ocean filled with invisible choreography, each motion purposeful, yet perfectly unplanned. Life had discovered grace long before it discovered thought. It is possible that in these ancient waters, the first sense of self emerged not in consciousness as we understand it, but in distinction. To move is to define a boundary, to say, here I end and there the world begins. When a cell changed direction, when it swam toward warmth or away from danger, it declared that separation. It was a whisper of individuality, the faintest spark of identity. The ocean, once a seamless mass of chemistry, now contained countless beings with their own trajectories. The Earth responded in kind. As life began to move, it altered the planet's chemistry yet again. The increased activity of these new organisms stirred oxygen into deeper layers of the ocean, spreading it farther than currents alone could carry. Sediments were disturbed, releasing minerals that had lain trapped for eons. Each motion, each twitch, each tiny displacement of water contributed to the evolution of the planet's systems. Even the smallest swimmers were participating in planetary engineering, whether they knew it or not. And as motion became widespread, communication followed. Life learned to sense not just light and temperature, but each other. Chemical signals became messages, warnings, attractions, invitations. Some cells released trails that guided others to food. Others secreted toxins to ward off predators. The sea became a conversation of molecules, a language carried on the currents. Every drop of water was alive with interaction, every exchange a whisper in a growing dialogue of existence. The energy of movement transformed the oceans into a vast, invisible network. For the first time, ecosystems were not static layers of life, but dynamic systems in motion. The surface teemed with photosynthetic organisms, the middle waters pulsed with grazers and hunters, the depths waited for what drifted down. Each level fed the next, cycling endlessly. The ocean had become a moving body, a single organism composed of countless smaller ones, all breathing, feeding, and flowing together. If one could have drifted through that sea, it would have felt alive in every direction. The water would pulse faintly against your skin, stirred by invisible swimmers. The light would shift and shimmer, broken by bodies too small to see but too numerous to ignore. There would be no silence, only the hum of motion, the quiet vibration of life at work. Every inch of the ocean was awake, every molecule participating in the rhythm of growth. This new age of motion laid the groundwork for everything to come. The evolution of muscles, of limbs, of wings, all of it began with those first flickers of movement in ancient water. The pattern was set. Life, when given energy, would not rest. It would explore. It would push. It would find ways to move not only through space but through possibility. Oxygen had done more than make the world breathable, it had given life the means to dream. Movement was the first expression of that dream. From it came curiosity, adaptation, exploration. The first currents of thought were written in the motion of these cells, the first will in their direction, the first future in their persistence. Even now, when you watch a school of fish turn as one, or see birds trace shapes across the sky, you are witnessing echoes of this ancient discovery. The choreography began in those primordial seas. In the moment when life realized it could do more than exist, it could respond. That response became motion, and motion became everything. The pulse of the heart, the rhythm of the tides, the orbit of the planets themselves. The rise of movement was the planet's first dance, a silent symphony conducted by light and breath. The world that had once been static now shimmered with motion, every organism part of a grand, flowing composition. The Earth was no longer just alive, it was dynamic. It had learned how to move, how to feel, how to change not only in time but in space. And from that simple act of motion, the story of life unfolded onward, forever in rhythm, with the breath that first made it possible. 17. The colours of motion. As the oceans filled with movement, the world began to shimmer in ways it never had before. Light, once filtered only through the haze of minerals and drifting plankton, now glinted off living surfaces that bent and curved and turned. The seas had become alive not only with activity but with colour that changed with motion, that caught the sunlight and fractured it into 1,000 hues. This was the age when life discovered visibility, when the silent chemistry of survival began to paint itself into art. Before, colour had been incidental. The greens of photosynthetic organisms, the rusty reds of oxidized iron, the faint blues of clear water, these had been natural accidents, consequences of sunlight and chemistry. But now, with motion and interaction came the need to stand out or disappear. Light became both an ally and an adversary. Some organisms learned to use it to hide, blending perfectly into their surroundings. Others learned to flaunt it, flashing and glowing to attract or warn. The oceans had become a vast, fluid canvas where colour carried meaning for the first time. The simplest hues came from the pigments life already knew: chlorophylls and carotenoids, phycobilins and flavins. But now they began to arrange themselves in new combinations, each tuned to a different wavelength of light. The shallows glowed with bright greens and golds, where sunlight was strongest, while the deeper layers turned crimson and violet, absorbing the dimming spectrum that trickled down. The sea was no longer uniform. It had depth and gradient, emotion and tone. Every shade told a story about the creatures that wore it. Imagine drifting through those waters billions of years ago. You would see ribbons of colour sweeping past, swirling veils of algae rising toward the light, golden threads of plankton stretching across the currents. Every wave of your hand would scatter them like dust in sunlight. Occasionally, you might see flashes of something brighter, tiny organisms glowing faintly from within, their bioluminescence pulsing like distant stars. These were the new artists of the ocean, using chemistry to make light in a world still young enough to marvel at its own illumination. Bioluminescence began as a side effect, an accidental release of energy from reactions involving oxygen. But what began as coincidence became adaptation. In the deep oceans, where sunlight never reached, life found ways to create its own light. Some used it to lure prey, others to communicate, still others to disguise themselves against the faint glow from the surface. The first living lanterns flickered into being, transforming darkness into a living constellation. The deep sea became its own sky, filled with drifting stars that moved and fed and multiplied. Colour, once passive, had become expressive. It was a language of survival, a system of signals written in wavelengths, and the more life moved, the more this language evolved. Predators with simple eyes, patches of light-sensitive cells, began to perceive differences in brightness and hue. Prey, in turn, evolved pigments and patterns to confuse them. Stripes, spots, and shifting tones appeared, each one a tiny experiment in deception and display. The ocean had become a theatre, each creature both actor and audience, each colour a line in the dialogue of existence. But colour was more than communication, it was power. The same pigments that absorbed light also protected against it. Oxygen, while life-giving, could be destructive when struck by the sun's ultraviolet rays, forming reactive molecules that damaged cells. Pigments served as shields, absorbing and dispersing this energy harmlessly. Every hue, therefore, was both an aesthetic choice and a matter of survival. Life had learned not only to live in light, but to live with it, to transform danger into beauty. The blue sky above, mirrored by the blue sea below, had set the tone for this new world. The planet's palette was expanding, blending chemistry with artistry. Red sediments on the sea floor, green blooms in the shallows, gold glimmers at dawn, the earth was beginning to look alive in every sense. And within this growing vibrancy, motion became performance. Schools of microorganisms drifted together, their pigments flashing in coordinated rhythm as they followed the light. The first true symmetries in movement and colour were being born. As organisms grew more complex, their surfaces became canvases for intricate designs. Some learned to refract light through layers of translucent tissue, creating iridescent, shimmering colours that changed with angle and motion. Others developed structural colours, using microscopic patterns to bend light into rainbows. These were the first reflections of what would one day become the colors of feathers, scales, and shells. But here, in this ancient sea, they were purely elemental expressions of light, meeting life, form, meeting function. The interplay of color and motion began to shape ecosystems in profound ways. In the clear waters near the coasts, brightly pigmented organisms dominated, using light to feed and communicate. In the deep, where darkness ruled, bioluminescent species reigned, their glows painting ghostly trails through the blackness. The boundary between these two realms, the twilight zone, became a place of mystery and transition, where color faded into light and light into darkness. It was here that the dance of attraction and evasion became most intricate. In this twilight, early multicellular creatures began to sense not only light but contrast. They could tell shadow from shimmer, movement from stillness. Eyes, still primitive but revolutionary, were forming. These light-sensitive structures gave their owners an advantage. They could find food more easily, avoid danger more quickly, and recognize one another across the shimmering void. The birth of vision was, in many ways, the culmination of the world's color, its moment of recognition. The planet, through the eyes of its creations, was beginning to see itself. The relationship between light and life deepened from there. Day and night became more than cycles, they became rhythms of existence. Some creatures learned to rise with the dawn, basking in light and releasing oxygen in kind. Others learned to retreat into darkness, resting and conserving. The ocean pulsed with this pattern, a planet-wide inhale and exhale tied to the turning of the earth. The blue world had become aware of time, its days marked by the changing color of light. If one could have hovered above the sea during this time, looking down through its surface, the sight would have been breathtaking. From morning to night, the colors of the water would shift and shimmer like liquid glass greens melting into blues, golds into purples, silvers into black, every hue a reflection of life beneath. The sunlight that once only warmed the world had become the brush that painted it, stroke by patient stroke. The beauty of this transformation was that it required no mind to conceive it, no plan to direct it. It emerged from necessity and patience, from the silent collaboration of light, chemistry, and breath. In this harmony, there was no waste, only renewal. The pigments that absorbed one wavelength reflected another. The light that nourished one creature revealed another's camouflage. The balance was exquisite, unplanned yet perfect, as though the planet had decided to adorn itself simply because it could. Even now, the echoes of this ancient age remain. The bioluminescence that glows in deep-sea creatures is the same chemistry that once flickered in those early oceans. The colors that shimmer in the wings of butterflies and the feathers of birds trace their lineage back to the first pigments that shielded microbes from sunlight. Every reflection, every glint, every hue on Earth is a descendant of this age of color and motion. And so the ocean continued its dance, alive with shimmering beings, each moving in rhythm with the others, each catching and reflecting the light in its own way. The sea had become both mirror and memory, recording every shade, every motion, every fleeting burst of luminescence. Beneath the blue dome of the sky, the world glowed from within a planet, painting itself, dreaming in color. The colors of motion were more than beauty. They were the first language of the planet, the first sign that life had begun not only to exist, but to express. Through light, the earth had found a way to speak, softly but unmistakably, in the spectrum of its own creation. Every ripple of the sea, every shimmer beneath its surface, was a word in that ancient language, a conversation between life and light that has never truly ended. 18. The calm before the bloom. By the time the oceans had learned to shimmer with motion and color, Earth had entered a long and gentle pause. It was a stillness that felt almost like anticipation, a quiet drawing of breath before something vast and irreversible. The seas were rich now, thick with life and rhythm, their balance nearly perfect. Oxygen moved freely between air and water. The continents, though barren and quiet, were slowly gathering their own thin veils of microbial life. The skies were clear, the light soft, the temperature kind. It was a planet in equilibrium, unaware that it stood on the threshold of its first true awakening. From above, Earth would have looked serene, Vast blue oceans stretched uninterrupted from horizon to horizon, their surface broken only by slow drifts of white clouds. The continents were dark and stony, outlined by pale strips of sand and salt where the waves had worn them smooth. There were no forests, no deserts, no flowers. And yet, beneath that calm, the planet was teeming with invisible possibility. The seas were alive with potential, with organisms that were learning how to grow, how to organize, how to endure. The eukaryotic cells that had once drifted aimlessly were now experimenting with cooperation. They formed colonies, filaments, and clusters. Some began to specialize, developing structures for feeding or anchoring. Others combined, merging into new kinds of beings entirely. These experiments were slow, fragile, and often failed, but they were relentless. Life was learning how to work together, how to share its energy, how to build systems that could outlast individual cells. The quiet calm of this era was the pause between invention and revelation. It's difficult to imagine this stillness, because our world today is defined by motion and sound. But in that distant age, everything happened slowly. The tides moved like thoughts. The growth of a colony could take centuries. The colors of the ocean changed only with the seasons, and the air carried no sound but wind and water. Yet even in that near silence, the planet was busy with transformation. In the deep, unseen places of the sea, life was preparing its next act. Oxygen had changed the rules. It allowed organisms to use energy more efficiently than ever before, and with that energy came the ability to grow larger. But size required structure, and structure required cooperation. To become multicellular, cells had to communicate to know when to divide, when to specialize, when to sacrifice themselves for the good of the whole. It was a new kind of intelligence, not of mind, but of pattern. The ocean was learning how to think with its living parts. In the shallows, the first truly complex colonies began to take form. They looked nothing like the creatures we know today. They were soft, translucent, and delicate, like ribbons of gel or thin veils of tissue swaying in the current. Some formed flat sheets that rippled with the tides. Others grew into branching forms, like underwater trees of light. They were not yet plants, not yet animals, but something between an experiment in complexity, testing the boundaries of what life could be. These organisms existed in a fragile balance. Too much sunlight, and they burned. Too little, and they starved. Predators, still microscopic, could tear through their tissues with ease, yet they endured. Each failure was followed by a quiet refinement, each generation learning from the chemistry of the last. Life, for the first time, was evolving not through chaos, but through design, slow, deliberate, elegant. The oxygen-rich seas glowed with abundance. Every breath of air that escaped the waves carried the scent of this new creation. The skies were filled with traces of ozone, protecting the surface from the sun's harshness. The world had grown safer, kinder, and more patient. Even the climate seemed to settle into a rhythm of stability, as if the planet itself were giving life time to prepare for something extraordinary. And yet, there was tension beneath that calm. The balance that had made the world stable was also delicate. Oxygen, though life-giving, was volatile. A shift in the ocean's chemistry could turn it from sustenance to poison again. Volcanoes still breathed carbon dioxide into the air, and the planet's crust was restless beneath its calm surface. The Earth was holding its breath, as if aware that another great change was coming. In the deep, where sunlight never reached, new kinds of organisms were emerging. They lived around vents that spewed warmth and minerals from the core, feeding not on light, but on chemistry. These creatures formed their own ecosystems, independent of the sun, thriving in darkness. They were ancient in design, yet new in purpose. Proof that life could exist anywhere. Energy flowed. The diversity of the planet was expanding, and with it, resilience. Life was no longer limited to the shallow, illuminated waters. It now belonged to every depth and shadow. If you could have traveled through these oceans, you would have seen the spectrum of creation at work. Near the surface, sheets of green and gold shimmered in the light, their pigments catching the sun. Below them, darker organisms glowed faintly, bioluminescent and strange, pulsing in the quiet. On the seafloor, Colonies formed domes and ridges, building miniature landscapes out of living matter. It was a world both tranquil and busy, a planet creating art at the speed of geology. Everywhere, oxygen moved like invisible music, linking the living to the non-living, connecting every breath to every ripple. The planet's cycles had become self-sustaining. Rain fed the oceans fed the air, and the air fed life. It was the first time Earth had achieved true homeostasis, a system capable of maintaining its balance across vast stretches of time. It was as though the planet had found its heartbeat, a steady pulse that resonated through every element of its being. But nature rarely lingers in perfection. The calm before the bloom was not a state meant to last forever. It was the necessary stillness before movement, the pause between inhalation and exhalation. Life was gathering strength, accumulating energy, evolving in silence. Soon, that silence would break. The world would erupt into diversity, into form, into an explosion of complexity so vast that it would redefine what it meant to be alive. The Cambrian explosion was still far on the horizon, but its seeds were already here in every colony, in every filament, in every fragile experiment beneath the sea. The genetic foundations for eyes, limbs, and nervous systems were quietly forming, hidden in the blue depths. The Earth was building its future, cell by patient cell, dream by patient dream. The calm that filled the planet then was not the stillness of emptiness, but of anticipation. It was the silence before a symphony begins, the moment when all the instruments are tuned and waiting. The air was ready, the water was ready, the light was ready. Every molecule of oxygen, every grain of sediment, every whisper of current was part of a world poised on the edge of creation. If the planet had consciousness, perhaps it felt a kind of excitement in that age, an awareness that its long labor was nearing a turning point. After billions of years of slow preparation, life was about to step into its own light. The stage was set, the actors were gathering. The script, written in the language of chemistry and breath, was ready to unfold. The calm before the bloom was the last moment of innocence in Earth's story. It was the deep breath before the crescendo, the still water before the storm of color and form. Beneath that endless blue, the seeds of motion, structure, and consciousness waited in quiet harmony, ready to awaken. And when they did, the world would never again be still. 19. The awakening of shapes. The stillness that had cradled the world for so long was beginning to stir. The oceans, once content to drift in balance, now shimmered with hints of new geometry. The planet had entered an age of design not imposed by any hand or thought, but by the patient mathematics of evolution. The calm that had stretched for eons began to fracture into movement and form. Life, which had spent billions of years mastering how to exist, was beginning to learn how to become. It started softly, almost invisibly. The filaments and colonies that had long swayed with the tides began to experiment with structure. They bent and folded, branching into patterns that captured light more efficiently. Some grew denser, forming layers to protect their inner cells. Others developed simple skeletons made of silica or calcium, stiffening their forms against the current. For the first time, the world of the living was sculpting itself into permanence. The age of shapelessness was ending. These early architectures were not yet animals or plants, but they hinted at both. Some creatures began to anchor themselves to the seafloor, filtering nutrients from passing currents. Others floated freely, propelled by the slow waving of cilia. Their bodies were symmetrical now, some radial, like the spokes of a wheel, others bilateral, divided neatly down the middle. It was as if life had begun to understand balance, not just in chemistry, but in form. Each new shape was an answer to a question the ocean had asked, and the questions were endless. In the shallows, the sunlight created gradients of energy, and these gradients shaped behavior. Organisms near the surface developed broad, flat structures to capture more light. Those in dimmer depths evolved bodies suited for movement instead. The ocean floor became a gallery of design curves, spirals, and fronds unfolding across the sand. Even the simplest structures displayed an elegance that seemed deliberate. The planet was not merely alive, it was composing itself. The rise of structure brought with it a new concept, the inside and the outside. For billions of years, life had been little more than a membrane wrapped around fluid, open to the world. But now, complexity required protection. Some cells began to fold inward, forming chambers and cavities. These internal spaces allowed for greater specialization, for systems that could work independently within the same organism. The first guts, the first circulations, the first nervous threads, they all began as folds in the fabric of simplicity. The oxygen that had filled the atmosphere made this evolution possible. It powered the energy-hungry process of building tissues, fusing molecules, and maintaining order against entropy. Each breath of the sea carried with it the potential for creation, and life used that gift to sculpt itself with greater precision. The oceans were alive not only with color and motion now, but with intention structures designed to survive, to thrive, to last. It's easy to think of this period as purely biological, but it was also deeply aesthetic. The new shapes were not random, they followed the logic of flow, of efficiency, of beauty. Spirals emerged because they distributed energy evenly. Spheres formed because they enclosed the greatest volume with the smallest surface. Patterns repeated because repetition meant stability. The language of nature was geometry, and the ocean was its first canvas. The seafloor, once a flat expanse of sediment and microbial mats, now had texture. Pillars and domes of living material rose from it, swaying gently with the current. Some organisms formed lattices of calcium carbonate, laying the groundwork for reefs that would one day shape entire coastlines. Others built spicules of silica, like glass sculptures glowing beneath the light. The world was beginning to crystallize in ways it never had before, and within these new forms, motion took on new meaning. The earliest multicellular creatures could contract their tissues, bending and undulating with purpose. Muscles were still primitive, mere strands of coordinated cells, but they gave life a new power, the ability to change shape at will. No longer entirely at the mercy of the current, some organisms could push themselves through water, even if only in slow, graceful motions. The still world had learned to move not just individually, but deliberately. In that motion was the hint of awareness. Organisms began to sense their surroundings more deeply. Simple nerve networks evolved, capable of detecting pressure, light, and chemical gradients. A creature could now react with precision, moving towards safety or sustenance. The ocean had become a living map, full of invisible lines of sensation and response. For the first time, life was beginning to perceive itself in space. This awakening of shape and sensitivity was not sudden. It was the work of millions of generations, each one refining what came before. The fossil record from this time, rare and delicate, shows faint imprints of these early experiments. Soft bodies pressed into stone, ghostly outlines of forms that look both alien and familiar. Some resemble leaves, others fans, others abstract patterns that could be mistaken for art. These were the ancestors of everything that would come, the prototypes of symmetry, of movement, of complexity. The calm that had once defined the oceans was slowly replaced by quiet struggle. Movement led to competition, and competition led to innovation. Those that could move faster or hide better had an advantage. Those with stronger bodies or sharper senses survived. Evolution, once a patient sculptor, became a restless artist. Life began to diversify, to explore every possible shape, every possible way of existing. The oceans were no longer simply alive, they were creative. And yet, even in this growing complexity, there remained a kind of peace. The earth was still gentle, the climate stable, the currents reliable. There was room for experimentation, for mistakes, for rebirth. This was the great rehearsal before the grand performance of the Cambrian explosion, the time when the foundations of all future life were quietly being laid in silence and light. If you could have stood on a rocky shore then and peered into the shallows, you would have seen a world both alien and familiar. Sheets of translucent creatures clung to the stones, rippling with the tides. Tiny forms drifted past, spiraling in the light. Threads of filamentous algae waved in green ribbons, shimmering like silk. There was no sound, no shadow of birds or trees, only the soft pulse of the sea, the planet breathing in shapes that had never existed before. It was in this moment, suspended between simplicity and explosion, that life discovered architecture, not the kind built with hands or thought, but with instinct and necessity. Every form had purpose. Every structure was a solution. The Earth itself had become a designer, using evolution as its art, physics as its rule, and time as its tool. The awakening of shapes was more than biology, it was the beginning of identity. For the first time, life took recognizable form. For the first time, the planet could look upon itself and see pattern where there had been chaos, design where there had been diffusion. It was the dawn of diversity, of individuality, of expression through form, and soon that expression would erupt into brilliance. The calm, balanced world that had nurtured these early experiments would give way to abundance, to ecosystems of unimaginable color and structure. But here, in this moment before it all began, the world was perfect in its simplicity, a vast, breathing canvas of geometry and light, waiting for the bloom of creation that would soon sweep across the seas and make Earth truly alive. 20. The dawn of the living Earth. It began, as all great changes do, almost imperceptibly. The ocean, which had for so long been the silent cradle of life, started to stir with an intensity it had never known. The balance that had held for eons was shifting. From the stillness that had once been the Earth's heartbeat came a pulse, slow at first, then gathering strength. This was not the chaos of catastrophe, nor the violence of fire or ice. It was the arrival of abundance. The planet, after billions of years of preparation, was about to awaken into fullness. The calm before had been necessary, like the deep inhale before a song. Now, finally, it was time for life to sing. Everywhere, in every depth and current, the living world began to multiply in both form and purpose. The shapes that had been testing their patterns now grew bolder, more intricate. Bodies thickened, tissues strengthened, senses sharpened. For the first time, the seas were filled not only with life, but with life aware of other life. This was the dawn of interaction, the beginning of ecosystems that could think, feel, and respond in ways the Earth had never seen. The Cambrian world that emerged from the long quiet was a place of surreal beauty. It was as though the planet had begun to dream vividly for the first time. The seafloor was carpeted with soft-bodied organisms, some leaf-like, some spiked, some shaped like fans or spirals. Above them, delicate swimmers drifted through shafts of sunlight, their transparent bodies glowing faintly in the filtered blue. The water itself was alive, each drop carrying countless particles of light and motion. The still planet had found rhythm. It was here that the architecture of evolution became visible, almost flamboyant. Creatures of every imaginable form appeared within the span of a geological moment. Some developed shells and exoskeletons to protect themselves. Others grew appendages for grasping or swimming. Eyes evolved independently, in many lineages, each one a new window to perception. For the first time, the ocean was not only alive, but aware it could see itself. The ancient blue world was now filled with gazes, each creature a mirror reflecting the presence of another. Predation, once a subtle act of absorption or chance contact, now became a pursuit, movement sharpened into intention. Organisms that could sense direction began to chase, and those that could not learn to hide. The ocean floor turned into a labyrinth of life, each form shaping the destiny of another. In this new interplay of fear and curiosity, evolution accelerated with breathtaking speed. The quiet cycles of the past gave way to a dynamic, pulsing equilibrium, a balance maintained not by stillness, but by endless motion. If one could have stood at the edge of a Cambrian shoreline, the view would have been astonishing. The shallows would shimmer with swarms of tiny creatures, their bodies catching the light like dust motes in water. The sands would shift under mats of living film, while beneath the waves, coral-like colonies began to rise. Transparent jelly-like forms drifted near the surface, while strange, armored animals crawled below. The planet had learned to sculpt itself not just through geology, but through biology. The world was now a living mosaic. This explosion of life was not chaos, it was response. Oxygen had given the planet energy. Now evolution used that energy to fill every possible niche. Where light reached, photosynthesizers flourished. Where darkness reigned, scavengers and chemotrophs thrived. Every layer of the ocean became an ecosystem in itself, connected by the endless cycling of nutrients and breath. The planet had achieved complexity on a scale it had never known. Every motion, every inhalation, every fragment of decay contributed to the whole. The Earth was no longer a stage for life, it was life. The shapes that now moved through the water were unlike anything that had come before. Some were armored, their bodies encased in plates of calcium carbonate or chitin. Others were soft and flexible, adapted for speed and stealth. Worm-like forms tunneled through the sediment, churning oxygen into the seabed. Trilobites, among the first true animals with jointed limbs and complex eyes, crawled across the floor, their shells glinting faintly under the filtered sunlight. Above them, early predators like anomalocaridids glided with grace, their bodies streamlined for pursuit, their eyes capable of seeing in multiple directions at once. The ocean had become an arena of strategy and design, and yet, for all its complexity, this new world was peaceful in its own way. The balance of creation and destruction was exact, every death feeding new life, every adaptation leading to another. The oxygen that filled the atmosphere continued to cycle, linking every breath in an unbroken chain. Even the smallest plankton, drifting unnoticed in the currents, played their part, turning sunlight into the energy that powered this grand symphony. The entire planet was an orchestra of chemistry and motion, each note resonating through the air and sea. The continents too were changing, though slowly. The land, still barren and harsh, had begun to host faint traces of microbial life, thin films of green clinging to rocks, colonies growing in the cracks where moisture collected. The first whispers of terrestrial existence were beginning. For now, life remained mostly in the water, but the pull of sunlight, air, and untouched ground was irresistible. The planet was preparing for another transformation, one that would eventually turn its desolate continents into forests, rivers, and plains. But in this moment, this shimmering age of the early Cambrian, the Earth was at its most ethereal. The light that filtered through the clear atmosphere and shallow seas created a world of iridescent wonder. Every wave carried reflections of living color. Every ripple distorted the shapes of drifting organisms below, turning them into fleeting patterns of motion and light. The planet glowed, alive from core to surface. If you could have watched it from orbit then, you would have seen a sight that was both familiar and otherworldly. The blue of the oceans, the white of clouds, the gentle curve of the horizon, it would look like home. But beneath that familiar beauty was something we can only imagine, an entire world in the act of invention. The ocean sparkled with movement, the atmosphere shimmered with breath, and deep below the waves, life whispered to itself the first stories of consciousness. This was the dawn of the living Earth, not just a planet with life upon it, but a planet that was life. Every process, from wind to tide to metabolism, was interconnected. The air was the exhalation of the ocean. The ocean was the memory of the rain. The rain was the heartbeat of the sky. The world had become self-aware in the only way it could, through the vast interdependence of its living systems. It no longer merely hosted existence, it was existence. As the days passed into eons, evolution would continue its endless dance. The creatures of the Cambrian would rise and fall, replaced by new forms, new experiments, new expressions of the same energy that had filled the air with breath. The continents would drift, collide, and fracture. The skies would change. The balance would tilt and correct, again and again. But the pattern established here, the endless renewal of form and function, would endure. The Earth had learned how to create itself, again and again, forever. The dawn of the living Earth was not a single moment, but a revelation spread across ages. It was the realization that life was not a visitor, but the planet's own reflection, its way of understanding itself. The oxygen that had once been mere chemistry had become awareness. The seas, once mirrors of light, had become mirrors of thought. The Earth had opened its eyes, and through the eyes of its creatures, it saw its own beauty for the first time. And so, beneath the boundless blue sky, under the warmth of a gentle sun, the planet breathed deeply, awake at last. Its oceans rippled with color and motion, its air shimmered with life, and every gust of wind, every flicker of light carried a single truth. The world was alive, and it would never stop becoming.